Well, hello there. Welcome to MV Tutors. My name is Pilakasli Manana, and we will be doing this paper right here. This is the 2022 May paper, paper 2. This is for mathematics. Okay, and if we look up here, this is our question number 1. Well, if this is what you want to do, then you came to the right place. Let's get right into it. Now, question 1 says the table below shows the mass in kg of the school bags of 80 learners. So now these are learners at a school that have bags. Now we're talking about their actual school bags. Okay, and here we are given the masses in kg of the school bags. Okay, these are the masses of the school bags. Now, first question says write down the model class of the data. Now, if you know anything about mode, a model, well, that's we are talking about the frequency that is showing the most. So if we look at the frequency, the biggest frequency is 21. So the model class of mass is 9 to 11. So that's how we're going to answer this question. This is 1.1, and we're just going to say 9 to 11. That's how we're going to answer it. That's it. Next question says complete the cumulative frequency column in the table on the answer book. Well, it's not there, so we pretty much going to have to do our own. Okay, so let me just, I should have done this before I started with this class, because now I'm wasting time busy doing lines over here when this time I should be spending actually filling in this thing. Okay, so this is the cumulative. Starts at 6. We have to add 18. Let's get a calculator. So we're going to say 6 plus 18, and we get 24. So we put 24 over there. 24 plus 21. And so plus 21, we got 45 right there. And then plus 19, just like that, and we got 64. All right, and then we gotta say plus 11, we get 75. 75 like that, plus 4, and we get 79, plus 1, and that's 80. Okay, that's it. We're done with that question. Now it says draw a cumulative frequency graph, guys, for the given data on the grid provided in the answer book. So what we need to do to draw this graph, we need another column over this side. I'll make it maroon. Over the mass that's between 5 and 7, that's going to be 6. Between 7 and 9, that's going to be 8. Between 9 and 11, that's going to be 10. Between 11 and 13, that's going to be 12. Between 13 and 15, that's going to be 14. This one is going to be 16, and the last one is going to be 18. Okay, so what we want to do here then is that we actually want to put this on our x, right, and then that the cumulative is going to go on our y-axis. Okay, let me just put axis there. That goes to the x-axis. Right, now let's go down to the question this side. Oh, what's going on? I need a graph paper. Do have a graph paper right there. Okay, so I'm gonna go ahead. I don't want green, let's use red. Good. Okay, so on the X, I said we have to go up to 18. So let me try, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, let's just put one more for control, 19. And then on the Y, we have to go up to 80. Okay, let's try 5. Let's go up to 5. So it's gonna be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and then 80. Well, you might not see it, but that's it. And then now we have got these values. So these are the cumulative ones. Okay, and then here we have the mass, right? Okay, let's use a different color now. Let's go for blue. Okay, so the first one is 6 and 6, which is probably going to be somewhere there. Okay, the next one is 8 and 24. There's 8. Let's go up 24. We got 20, 25, somewhere there. I don't know why it keeps blinking this thing. And then the next one is 10 and 45. So we go 10, we go 45, up there. Perfect. And then the next one, we're gonna go 12 and 64. So 12 and 64. 64 is probably somewhere there. What's going on with this thing? I don't like it. Anyway, 14 and 75. There's 14, go up 75 right there. And then next one is 16 and 79. 16 and 79. 79 is going to be somewhere there. And the last one is 18 and 80. 18 and 80. Right there. Okay, let's try to join them. Nice smooth curve. Look at that. Let's go through each and every point. Very important. Look at that. It has to go to 0 right there. Okay, something like that. Well, there we go. Okay, and then the next question says, use the graph to determine the median mass of the data. Okay, so to determine the median mass, to determine the median mass, we know that we basically have to say the formula of the median position. This is for position. Okay, let me just say position so that you don't think this is the median. Basically just a half, or 2/4, which is a half, n plus 1, and our n is a total number, which is cumulative, plus 1 is 81. So if you put this in a calculator, it's probably 81 divided by 2, that's 40.5. So what that means for us then is that we're gonna go to a position at 45, which is somewhere there, and then we go I should probably use draw a straight line here. Let's see if I can get a straight line. Where's my straight line? Can't see it, but it's fine. Let's just continue. For you probably do it much nicer yourself, and then you go down. Okay, using a ruler. So it's about 10, approximately 10. Yeah, let's say that. So our answer then is approximately 10. Use the median mass. The median mass is approximately 10 kgs. Good. All right. Now let's see this question. The next question over here. It says the international guideline for mass of a school bag is that it should not exceed 10% of a learner's body mass. So that means that if a person weighs 100, the bag should not exceed 10. Okay. Now it says calculate the estimated mean mass of the bags. Well, there's basically two ways of doing this. You can use a calculator or you can do it by hand. Let me show you both. Let's start with the calculator. Okay, so in your calculator, what you're gonna do is that you basically gonna use that for your x and that for your y. So we'll just go mode. Wait a minute. We're dealing with frequency here. So the first thing you want to do is go shift and then mode, because we need to set it up. And then we're gonna go down because we want the stat mode, which is number 4. We press 4, and we want to turn the frequency on, so we press 1. Okay. And then what that has done is that when we go to mode and then we go to stat, which is number 3, and then we go to one variable, there is a frequency table. If we didn't turn on the frequency, this column here, the frequency column would not be there. Okay, so now we can work with it. We're going to put these x values, which is 6 equals 8 equals 10 equals 12 equals 14 equals 16 equals, and then the last one is 18 equals. And then we'll go back, we'll press 1, we press down, and then we'll go to the side to put the frequencies now. First frequency for 6 is 6. 3 is normal frequencies, not the cumulative one. So it's 6. Next one is 18. Next one is 21. Next one is 19. Next one is 11. Next one is 4. And then the last one is 1. Okay, there we go. And then we're gonna press the AC here, or on. We don't need it anymore. And then we'll go shift, and then we'll go stat, which is number 1 here. You can always tell shift works with the orange colors, alpha works with the red ones. So stat is orange, that's why we press 1. And then what we are looking for is a variable, so which is var is number 4. We press 4, and we want the mean, right? Because the question asks us to calculate the estimated mean mass. So we'll press number 2 of this calculator, and then equals, and it gives us 10.675. 10.675. Why did I do that? Okay, anyway. So this is question 1.5.1. We got 10.675. I said there's two ways. Now let me show you the other way of doing this. Basically what we want to do is well, we're just gonna put these numbers. Okay, so it's gonna be 6. Let me change the color because green, something about green I don't like. So it's 6 times 6. I'm putting multiplying the x values with the frequency, and then I'm gonna divide them by the total cumulative, which is 80. And then the next one is 8 times 18 plus 10 times 21 plus 12 times 19 plus 14 times 11 plus 16 times 4 plus 18 times 1, and all of this should be divided by 80. Okay, this is I don't know which one you'd find quicker, but that's what we do. So then we'll put the fraction. First of all, we need to go back to the normal mode, which is comp, which is number 1, and then we can put, there we go. Okay. Then we're going to say 6 times 6 plus 8 times 18 plus 10 times 21 plus 12 times 19 plus 14 times 11 plus 16 times 4 plus 18 times 1, and then we're going to go downstairs, put 80 there, and we get 10.675. See, it's the same number, 10.675. Same number, same answer. That's the mean. Right. Same. So 2 ways of doing it. You choose which one you like. So now the question this side then says the mean mass of the group of learners was found to be 80 kg. Okay. On average, are these school bags satisfying the international guideline with regard to the mass? Motivate your answer. Okay, so let's understand what the question is saying first. So first of all, they are saying the mean of the group. The mean of the group. Just want to go down, give myself more space. The mean of the group is 80. Okay, and remember they said this side it must be 10%. It mustn't exceed 10%. So let's get 10% of 80. 10% of 80 is 8 kg. That means this group here must have a bag that weighs 8 kg. But if you look at the actual weight of the bags, it's 10.675, which means it's exceeding 8 kg. Therefore, our answer will be no. Okay, it does not satisfy the international guideline. Why? Because, now this is just up to you, whatever English you can use, as long as it makes sense. I'm gonna say because the actual bags weigh more international guideline. International guideline. And then you can put there 10.675 kg is actually bigger than 8 kg. That's it. Well, that's it from my side. I hope you understood everything I was doing with you. If you liked this video, these explanations, please like and subscribe to our channel. It will help us and also help other learners to receive this material when they need it. Other than that, that's it from me. It's goodbye, and I hope you do enjoy the rest of your day. Well, welcome to MV Tutors. My name is Piragash Manana, and we are still doing the May-June 2022 Mathematics Paper 2 this time. And if this is what you are looking for, then you came to the right place. Let's get right into it. Now, question 2 says, the table below shows the size in carats and the price in rands of 10 diamonds that were sold by a diamond trader. The information is also presented in the scatter plot below. The least squares regression line, the data is shown. So they give us the information in this table. These are the sizes of the carats of the diamonds versus the price of the diamond. And then they've taken that information and they've plotted it in this graph here and then drawn the regression line. Okay, so that's what's happening here. This question is not very clear, but I'll try my best to read what it says. It says determine the equation of the least squares regression line for the data. Okay, so they pretty much want us to solve the equation of this line. Okay, so that's going to be 2.1. And what we need here is a calculator to do this really. Okay, so we're going to grab our calculator right here. And we're going to go to mode. Okay, and then we're going to go to stat. And then we're going to go to this second one because that's the formula we want. It's the formula of a line. A plus bx. Let me just put it here. Y is equals to A plus bx. Okay, this is just for your understanding. Okay, so we'll press number 2. There's frequency showing there. Let me show you how to get rid of that frequency because we used it to solve question number 1. Now we don't need it anymore. We need to turn it off. So we go shift, go mode, and then you're gonna go down, and then you're gonna go stat, which is number 4, and then frequency off. So we'll press 2, and then there we go. It's off. Now when we go to mode, we can then go to stat, and then we can go to that line equation. See, it's no longer there. Frequency thing. Okay. Anyway, we have our x values here, the size of the carat. So the x will put those numbers. The first one is 0.1 equals 0.15. 0.15 equals 0.2 equals 0.2 equals 0.3 equals 0.35 equals 0.4 equals 0.45 is the next one equals, let's see, what's the next? Okay, there's another 0.45, and then the last one is 0.55. Cool, it's 10 values. Then we go down, go to the side, we need to put the next values now. Okay, the price one. So the first one is 4,000 equals to 6,000 equals 6,500 equals 8,400 equals 9,000 equals 10,000 equals 13,440 equals, let's see what's the next values, 15,120 equals 16,800 equals 18,480. The last value. Cool. So we got all our values. The next thing we'll do, we'll press AC or on. What we are looking for then are the values of A and B. Okay, so we go shift, and then we'll go stat, which is number 1 here, and then we're gonna go regression line. That's REG, that's number 5, and then let's start with the value of A. So A is number 1, press number 1, and then we need to press equals. Okay, so A is 634.382. Let's just take 3 decimals plus B. Now we need B. Okay, press AC, we go shift, again stat, which is number 1, we go regression, number 5, and then we want the value of B. We just press number 2, and then equals, that's a value of 32189. How did I write this? Well, that's not how it is, but it's fine. 263, and then X. There's an X at the end there. Okay, I didn't have enough space to complete that, but 263X. That's cool. So that's our final answer in this question, because they asked for determine the equation of the list. There it is. Okay, next question. Not very clear, but if the trader sold a diamond that was 0.25 carats in size, predict the selling price of this diamond in rands. So now all we have to do really is just put this in an equation. 2.2, the equation is this one, because they want the price of this, and remember the price is the Y value. Okay, it's the Y value. It's the Y value over there. Okay, right here. There, it's the Y value. So when we come this side, we're solving for the Y value, and they gave us the current size, which is an X. So it means we just have to substitute the value of X. 634.382 plus 32189.263x. What was the value of X they gave us here in the question? 0.25. So we'll go 0.25. Okay, we need to put this in a calculator, so let's bring it back. There we go. So it's 634. But before that, let me just go back to the normal mode. Remember, we're still on stat mode, so we go mode. Normal mode is number 1 there. There we go. Cool. So then we can go 634.382 plus 32189.263 times 0.25, and then we get 8681. Okay, let's put that. So I'll put it in rands. Remember, these are rands, so it's 8,000 predicted to be 8,681.70 cents. That's it. Okay, let's go to the next question. Calculate the average price increase per 0.05 carat of the diamond. It's not too bad. So what we have to do with this one, it's like I'm not going to use that. I'll use these values over here. If you look from 0.1 to 0.15, the difference is actually the 0.05. So, well, if you don't believe me, let's put that in a calculation. So what did I say? I said if we say 0.0, sorry about that, this is what I want here. Not 0.0, go back again. If I say 0.15 minus 0.1, that's going to give me, let's put that in a calculator just so that you know it. So I said 0.15 minus 0.1, and that gave me 0.05, right? And then 0.15, the price is 2,000, right? Minus 0.1 is 4,000. I just said 2,000 and you guys kept quiet as if I was correct. 0.05 is 6,000. We'll cancel that. It's 6,000 minus 2,000, and that, I did it again. It's not 2,000 but 4,000, and that's going to be 2,000. Therefore, the price for the increase of a 0.05 carat is approximately 2,000 rand. Okay, that's how we get that one. And then it says it was later found that the selling price of the 0.35 carat diamond was recorded, okay, incorrectly. Okay, so let's take it piece by piece. They are saying here, let's get more space this side. So here, what they're saying here is that I'm going to change the color. Let's go blue this time. They are saying 0.35 was recorded incorrectly. This is for 2.4. The correct price is 11,500. Okay, when this correction is made to the data set, the correlation between the size and the price of these diamonds get stronger. Explain the reason for this by referring to the given scatter plot. So we have to refer to the scatter plot. Okay, originally 0.35 was given at 10,000, and they said this is the incorrect one, and then this was the correct one. Okay, so now what happens if 0.35 is actually the price of 11,500? Look at this. So 0.35 is there, so it's that one. Now they are saying if, and it's at 10,000 as you can see there. They're saying if it moves from 10,000 to 11,500, so 11,500 is probably somewhere over here. Okay, so now what's does this mean for the regression line? It means it becomes stronger, and they're asking us to explain why it's stronger. So the reason it's stronger is because it is closer to the regression line. We can write that sentence actually: stronger because it is closer to the regression line. Or let's write it like they wrote it here. What did they say? Square regression line. Squares to the squares regression line. That's it. That's it. Oh, that was the last question. Well, thank you so much for staying until this late. This is it. Please, if you liked this content, please like and subscribe to our channel. It will help us and help other learners to receive this video. Okay, other than that, I hope you understood everything. It is goodbye from me, and I hope you enjoy the rest of your day.
Hello everyone and welcome to MV Tutors. I'm Tulu and I'll be doing question 3 with you guys. Please don't mind the bad lighting and the oily skin. We're here for the maths. Alright, as I prepare, just zooming in, please don't forget to like our videos and subscribe to our channel. And please spread the word with those who are in matric, those who are upgrading. Share this information with them. Okay, so yeah, I hope you enjoyed question 1 and 2 and you were able to see where you went wrong, if you did go wrong. But otherwise, I hope it was a good paper. So question 3, it says in the diagram, we have A, B, C, and E being the vertices of a trapezium having BA parallel to CE. And D is the y-intercept of CE. So it's not quite clear, but yeah, that is basically the y-intercept. Okay, and now 3.1 says we should calculate the gradient of AB. Okay, so this is where you score marks because you've been calculating the gradient from, grade 10. So this should be very easy. So the gradient of AB, what are we expecting the value to be? Positive or negative? Well, it definitely has to be positive, right? If you get a negative value there, then you have done something wrong. So the y value of B is a half, and the y value of A is 3. Then we have the x value of B, which is 0. The x value of A is 5. Okay, so a half minus 3, that's going to be negative 2.5. And 0 minus 5, that's just negative 5. 2.5 is a half of 5. So basically our gradient is positive a half. Okay, this was what? 2 marks as expected. Alright, so let us go over to 3.2. And it says, determine the equation of CE in the form y is equal to mx plus c. So, what do we need to determine the equation of a straight line? Well, we need a point, first of all. We need a gradient. And because we know that AB is parallel to CE, they share, oh no, they don't share gradient. Their gradients are the same, okay? So, the gradient of CE would then be a half. And the point that we are going to use, well, we have E only, so we can only use E as a point. Then we take our equation y is equal to mx plus c, and we substitute what we know. Alright, so the y value of point E is negative 4. The gradient we know it as being half. The x value is 6, and now we're going to solve for c. And what are we expecting c to be? C would be the y-intercept, right? Which is D in this case. D is the y-intercept of the line CE. So we're expecting a negative value. If you get a positive value here, you know you are wrong. Alright, so we have negative 4, and a half times 6 is 3. If I take 3 to the other side, it'll be negative 3, and therefore C would be equal to negative 7. Okay, so now we can finally write down the equation. We have y is equal to a half x minus 7. Okay, so that is it. How many marks? 3 marks. We didn't labor that much, so that makes sense, but yeah, 3.3.1. So now it says calculate the coordinates of C. Okay, so what did they tell us here? They didn't tell us explicitly, but we can see that CD, oh, they did. D is the y-intercept of CE. By the way, if you want to get the coordinates of D, just a side note, D is actually 0 and negative 7. Okay, they didn't ask for it, we're just putting it out there for ourselves. So they did say in the information that CE and that CD is equal to DE. That is very important, because if CD is equal to DE, it means that D is the midpoint of line CE. Okay, so if that is the case, if I were to get the coordinates of C, I would use the midpoint rule or equation. Okay, so what is the midpoint equation? How do we implement it? So the midpoint of CE, I'm basically going to take the x-coordinate of C, plus it with the x-coordinate of E. I know we're used to subtracting, but in this case we are adding. Alright, and then the y-coordinate of C plus the y-coordinate of E all over 2. Okay, yeah, so the midpoint of CE is actually D. Alright, and we know the coordinates of D, which is 0 and negative 7. Okay, we don't know what the x-coordinate of C is, that's what we're looking for, but we know the x-coordinate of E, which is 6. Okay, that's all over 2. The y-coordinate of E is negative 4. Okay, that's all over 2. So what we do in this case, we will then equate the x's together and the y's together. So basically 0 from here would be equal to xc plus 6 all over 2, and then would have negative 7 being equal to yc minus 4 over 2, and then we're just solving, and then we're going to get the coordinates of C. Alright, so we have 0 over here. If we multiply 2 by 0, okay, therefore we know that the x-coordinate of C is negative 6. As expected, we are expecting a negative x-coordinate and a negative y-coordinate. Okay, and then if I multiply 2 to the other side, I get negative 14, yc minus 4. Therefore, yc is minus 14 plus 4, which should be equal to minus 10. Therefore, at the end, we are done getting the coordinates of C, which is minus 6 and 10. Okay, and it does make sense, right? Alright, and then 3.3.2, it says calculate the area of the quadrilateral ABCD. Okay, so ABCD is a trapezium. All right. I think let me just redraw this trapezium for ourselves. Don't mind the drawing if it comes out all how. Okay, so let me just erase this and just close it up there. Hopefully it matches. Okay, sorry. Okay, so we have with us So we have B, okay, A, B, C, and D and E. All right, so the area of a trapezium, okay, what you would do if you're going to calculate the area, it's quite similar to the area of a triangle, but not really quite, but kinda. So it is half, then you're going to take the length on top, okay, so half AB plus the length at the bottom, CE, and then multiply by the perpendicular height. Okay, now the temptation here is to think that AE is the perpendicular height, okay, because it looks like it, right? But they didn't say, oh, another thing, for you to actually use this equation, you must ensure that with this trapezium that the lines are parallel. If they're not parallel, you're not dealing with a trapezium, it's something else. So yeah, we need a perpendicular height if AE is not perpendicular. So how will we know that AE is perpendicular or not? We know that AB has a gradient of a half. Okay, so if I take the gradient of AB and I multiply it by the gradient of AE, I should get -1. All right, I know the gradient of AB is a half. I don't know the gradient of AE, but I am hoping that the gradient of AE is -2, because a half times -2 will give me -1. So let's just check out first if the gradient of AE is actually -2, because I can see it's quite a steep gradient. Okay, so if I were to get now the gradient of AE, okay, the y-coordinate of E is -4, y-coordinate of A is 3, the x-coordinate is 6, the x-coordinate of A is 5. Okay, so I have -7/1. So that's definitely not -2. Okay, so it's -7, it is not -2, therefore AE is not the perpendicular height. Okay, I'm not gonna write that down. But yeah, AE is not the perpendicular height, so that is crushing because wow, now we're gonna take time. Okay, it's 4 marks. Okay, they're making us labor. Because what I was going to suggest is that we get the distance of AB, we get the distance of CE, and we also get the perpendicular distance. That's the only way I can think of doing this sum. I feel like they're making us work a little bit too much for this. They should give us 6 marks. Alright, so now to get the perpendicular height, what are we gonna do? Here's what I'm suggesting. We know that the gradient of AB is a half, right? We know that the perpendicular height's gradient would have to be -2. So if I were to take a line from B to, this point here. So maybe, what am I missing? We can name this ABC. Let's name this T. Yeah. T, why not? T for me. All right, let's name it T. I know what the gradient is. It is -2. I need to get a point. I know we have a point here for B, which is 0.5. All right, so I can get the equation of BT. And why do I want the equation of BT? I want to get the coordinates of T. Okay, and why do I want the coordinates of T? So that I can use BT as my perpendicular height, and we can finally calculate the area of this trapezium. Okay, and the way of doing that, I'm going to take the line of BT and make it equal to the line of CE. We already have the equation of CE. We determined it in 3.2, so we're going to now get the equation of BT. Okay, so y BT is equal to mx plus c, and we know that the gradient is going to be -2, the x-coordinate of B is 0, the y-coordinate of B is a half, so C is equal to a half. Yeah, so then my equation, okay, would be a half x, -2x. Thank you for that correction. -2x plus a half. All right, so I have the equation of BT. I'm going to equate it to the equation of CE so that I can get the coordinates of T. Guys, I think I went about this the wrong way, but I can't think of another way of doing this. So I think in this case, it would be advantageous for you to learn how to do things speedily, so that even if you take a long way of doing things, you're doing it and not wasting so much time. Okay, so when you practice for exams, please, please, please work on your speed. All right, let's check out the equation for, so it's a half x minus 7. Okay, half x minus 7. So if I take a half x that side, I'm going to get negative 2.5x. And if I take a half that side, I'm going to get negative 7.5. So what is 7.5 divided by 2.5? I'm not going to start guessing. Okay, it's 3. So x is equal to 3. And then I'm going to take 3 and substitute it in any equation, any easy equation. So I'm just going to say, I have an alarm here that keeps going. So y is equal to negative 2 times 3 plus a half. You can take any equation, whether it's for BT or CE. You will get the same y value. You should get the same y value. So I have negative 6 plus a half, and that will be negative 5.5. So my coordinates for T in this case would be 3 and negative 5.5. You could say 11 over 2. It's really up to you. All right, so now we have the coordinates of BT, T, not BT. So we can go back to this question that they asked us. And like I said, this is really too laborious. Maybe I just went about it a very long way, but I really want to make sure that you guys understand what you're doing and you know of a method that works. Okay, so now we're going to labor again. We're going to get the distance of AB using the distance formula. We're going to get the distance of CE, and we're going to get the distance of BT. So AB, the x-coordinate of B is 0 minus 5, and I'm going to square it, plus a half minus 3, and I'm going to square. Okay, guys, I'm not going to write out the full equation of the distance formula. You know it. At this point in time in matric, you should know it. So, yeah, we can definitely go. It's this one where you say xb minus xa, and then you square it, and then plus yb minus ya, square it, and it's all under a square root. Okay, it's that one. But I believe that you know it, so we can just plug in values and go with it. So for CE, the x value for E is 6. The x value for C, I think it was negative 10. Can't recall. Oh, negative 6. So 6, negative 6. All of that is squared. And then the y values, I have negative 4, negative 10. If I recall correctly, the x coordinate of C is negative 6. The y is negative 10. Yo. Okay, there I am making silly mistakes. All right, so that is that. And then BT, so the y coordinate, let's just start with x. 3 minus 0 squared plus minus 5,5 minus a half, and we're squaring that. And guys, I'm just gonna plug that in the calculator as it is, so that I can get an answer. And yeah, so actually here we have, let me do it like this, we have 5 squared, right? That's 25. And then we have 2.5 squared. So it's basically 125 over 4. That's 31,25. So I have root 31,25. I don't want to lose the decimal places. That's why I'm not getting the root of it. Okay, and then there we have 6 plus 6. That is 12. 12 squared is 144 plus minus 4 plus 10 is 6. 6 squared is 36. So I have root 180. And then I have 3 squared, which is 9. And then I'm going to add negative 5 and a half. Negative a half is negative 6. Negative 6 squared is 36. So 45. Root 45. Okay. And then now we can plug in the values and finally determine what the area is. They didn't give us units, no? They didn't give us units, you just write units squared. So I have half, and then AB is root 31,25 plus CE, which is root 180, BT, which is root 45, and now we can finally get the answer. So I have a half, and I have root 31,25 plus root 180 multiplied by root 45, and our answer is finally 63,75. Wow guys, this was work but it was nice. 63,75 units squared. That is the area. I think the trick here was just to make sure that you have the correct perpendicular height, because I was honestly tempted to use AE until I thought, is it really the perpendicular height or not? So yeah, I hope you enjoyed this question. Oh, we have so much to do still. 3,4. Now if point K is a reflection of E in the y-axis. How I wish I could sketch on this thing. Alright, let me see if I can sketch. Let me pause and then get back to you. Okay, so I found a way of writing. Okay, let's get back to the question. So 3.4 says if point K is the reflection of E in the y-axis. So whenever you reflect something in the y-axis, so let's say you have a point here, okay, and it's on coordinate 4 and 2. If this point were to be reflected about the y-axis, okay, it would be this side, right? Now what happened? Your x became negative. It's the same value, 4, but it's negative, but your y value remains. So a reflection about the y-axis means your x values get a negative, but your y values remain the same. So I don't really have to sketch it for you, but I just wanted to show you that actually the y value remains the same and the x gets a negative. So if E, alright, is 6 and minus 4, remember the coordinates of C are minus 6 and minus 10. So I will get that a reflection, E would be somewhere here. Sorry, K. K would be somewhere here, where now its x coordinate gets a negative, so it's negative 6, but the y coordinate remains the same. So it's negative 4. Okay, so that is what that reflection would do. So what is K? K is then negative 6 and negative 4. Alright, so that's 3.4.1, and then 3.4.2. Calculate the perimeter of triangle KEC. Alright, so if I were to just draw that, so this is the triangle, and this has to be a line parallel to the x-axis. Okay, because we have the same x coordinate here, it's basically a straight line, right? So this is like a right angle triangle, right? And we know that we have a line parallel to the x-axis because you have the same y value. Okay, so if I'm looking for the perimeter of triangle KEC, I'm looking for the length of KE, the length of KC, and the length of CE. Then I'm going to add those up to get what the perimeter is, because that is what the perimeter calculation is like. You're taking the lengths of your shape and you're adding them up. So the length of KE, and in this case, guys, please don't go and use the distance formula, because they are all on the same line, meaning they have the same y value. You can just subtract the x values from each other. Okay, so KE, I have a value of negative 6 minus negative 6. Or you could have started at E. Okay, the x value for E is 6 minus 6. So in this case, because we're looking at an actual length, we're not going to take any negative. Our length, you can't get a negative 12, for example. It has to be we need to get the magnitude. It has to be positive. So in this case, KE would be 12 units. Okay, and then we're looking for KC. Again, they have the same x value, right? Yes, only the difference is the y values. So I'm just going to subtract the 2, all right? So I would have between negative 4 and negative 10. For me to get from negative 4 to negative 10, I would have had to move 6 units. Okay, so in this case, that would be 6 units. If you are uncertain, just take negative 4 minus 10. You'll get 6. All right. And then lastly, CE. Okay, so here we're going to use Pythagoras. So it's quite important that we know that we have a right angle triangle, else we'd be screwed. All right, so CE squared is basically equal to KE squared according to Pythagoras plus KC squared. And then to finally get CE, KE is 12 squared, which is 144. And then KC is 6 units, which is 36. And all of that is under a root, square root. Okay, so 144 plus 36, what is that? Okay, 144 plus 36, is it 180? Yeah, so we have 13,42. That's CE. Okay, let me see. Okay, 6 root 5. I think I prefer that. I don't want to start rounding off now. And now we can get the perimeter. These questions are long. And it's only 4 marks. Can you believe these people? Alright, so perimeter of triangle KC. It's basically KC. So perimeter of triangle KEC is equal to KE, which is 12, plus KC, which is 6, plus CE, which is 6 root 5, and that would be, so 6 root 5 plus 12 plus 6, and that is basically 49,42. So 49,42 units. Okay, this is not an area, so you're not squaring anything. And yeah, so that's 49,42 units. Okay, I just want to check this answer. It looks a bit weird. So we have, 12 plus 6 plus 6 root 5. Okay, 31,41. What did I do previously? 31,42 actually. 42 units. Alright, I don't know what happened there. Okay, but anyway, yeah, we're almost there. Took long, but here we are. So calculate the size of KCE. So Mama, basically, yes, my baby?
I'll go with Daddy.
Yes. So we need to get the angle of C, and this is our triangle here. Just gonna invert it, reflect it about the x-axis.
Mama.
Yes. Alright, so I've inverted the triangle, and now we can basically get the angle of C. You can use whatever because you have all the sides to a triangle, but yeah, you can use anything. So I would use 10. Okay, so if I were to say 10 C, it would be opposite, which is 12, over adjacent, which is 6. So basically C would be that, okay, and 2. So let's see what that amounts to. So 10, that's 63,43. Okay, and with that we are done. 63,43. 0.43 degrees and 21 marks. We labored. So here time was, yeah, I'll leave it there. Thank you for tuning in. I hope you learned something, and see you question 4. Hello everyone, and welcome to MV Tutors. I'm Solo, and I'll be looking at question 4 with you guys. We previously did question 3, and I hope that question 4 won't be as long as question 3 was. Alright, as per routine, please don't forget to like our videos and subscribe to our channel, and please spread the word to your fellow metric class learners and people who are upgrading. Just spread the word with people who would find this very useful. Alright, so it says in the diagram, the circle named in the diagram, the circle centered at M is drawn. Right, so we have T and R as the x-intercepts, and a tangent is drawn to the circle at K. Alright, when you hear tangent, you should think radius, tangent, what happens, perpendicular, what. So M is a point on the line y is equal to x plus 1. And 4.1.1 says write B in terms of A. So if M is a point, right, which has A and B as the coordinates, and they tell you that it lies on the line y is equal to x plus 1, the one thing you're going to think of doing is substituting the points of M, the coordinates of M rather, in this equation. So for the y you would have B, for x you'd have A plus 1, and there you have your 1 mark. Alright, and then 4.1.2, 5 marks, so we are going to labor. Calculate the coordinates of M. Oh, where do we start? It would have been nice if M was in between the origin and K, ne? So you just get the midpoint formula and calculate it, but that's not the case. So here's the thing. I do know that a tangent and the radius are perpendicular to one another. Alright? So I know from M to K, I have a radius. Okay? And I also know that from M to R, I also have a radius, because a line from the center of a circle to the circumference, that is basically your radius. And why am I pointing that out? I'm pointing it out because those are my only known points that I can use to make sense of how to get the coordinates of M. And so I know that the radius is equal to the radius. The radius is the same. So then what I'm trying to say is the distance of MK is equal to the distance of MR, which is basically the radius of the circle. So if I can just get the distance, then I can do something. Alright, so I'm going to use the distance formula, alright, where I will then take the x coordinate of K, which is 5, subtract it with the x coordinate of M, which is A, and that will be squared. Alright, the y coordinate of K is 7, the y coordinate of M is B. Alright, and I root all of that, because that is according to the distance formula. And I'm going to do the same thing for MR, right? So the x coordinate of R, that's 6 minus A, and that is squared. Then I'll have 0 minus B, and that's squared. So I now, at the end of this, can get an equation in terms of A and B. Okay, but where am I going with this? I have one equation so far and 2 unknowns, but remember 4.1.1, I had another equation, so I will have 2 equations, 2 unknowns, and I can solve for A and B. That's where I'm going with all of this. This is the strategy I am going with. I can't think of anything else at the moment, so let's use what we have. So the square roots are going to cancel out, and then I'm going to expand everything. If I expand 5 minus A squared, I'm just going to say negative A times negative A, that's A squared. I'm going to write it in the order I'm used to. So A squared minus 10A plus 25. Guys, this is me assuming that you are fine with the algebra at this point. Alright, if you are struggling here with me going a little bit fast or skipping steps, please do comment below and I can take you through it. Alright. And then we have 7 minus b squared, so I will take the b squared minus 14b plus 49. Okay, so I don't really need to put that in brackets. Actually, I don't even need these brackets too. I can just remove them. Yeah, if I had a negative, then yeah, the brackets would become in handy. And then 6 minus a, so I can say a squared minus 12a plus 36. And then here I have b squared. Okay, that's nice. So now I'm going to take what is common. So I have a squared here and a squared there. Those are cancelling. Okay, I have b squared and b squared. So again, those are cancelling. Let me just cancel them out so that I know I'm not going to use them. Then I have negative 10a and I have negative 12a. So if I bring 12a to the left, negative 12a to the left, I will have positive 12 minus 10. I'm left with 2a. Alright, and then I have that negative 14b. And then I have 25 over here and a 49 over there and a 36. Ooh, almost didn't see that. So I'm definitely going to need a calculator here. So if I take 25 and I add 49 and then I subtract 36, so I'm left with 38. Okay, so I have, yeah, plus 38. What else do I have? So I've used up everything. Okay, that's equal to 0. So, like I said, 2 equations, 2 unknowns. So I have b in terms of a. I'm going to substitute that in this equation. Alright, so 2a minus 14b, b is a plus 1, and then plus 38 is 0. Yo, imagine doing all this work and then you don't get the answer. How will I know what the answer is? I read the next question. They say if the coordinates of m are 2, 3. That is yeah, don't always depend on it, but it's a good guide. Okay, so I have negative 14a, negative 14 plus 38 is equal to 0. I'm going to take the numbers to the other side. So 2 minus 14, that will give me negative 12a. And then if I say negative 14 plus 38, that is 24. And if I take it that side, that will be negative 24. Okay, so a will be equal to 24 divided by 12, that's 2. A is 2. And yeah, we're on the right track. So I can rest easy. And then now I can get b. I know b is a plus 1. So b being a plus 1, it's going to be 2 plus 1, which is 3. Therefore, I can finally say the coordinates of m are 2 and 3. And then we can go over to question 4.2. Okay, so it says if the coordinates of m are 2, 3, calculate the length of the radius of the circle. Okay, so I already said that the radius is equal to, mk or mr. So I can just copy any of them. Alright, so I'm going to say mk. So radius. Yeah, so the radius, which can be mk, will be equal to that thing that I copied. Okay, so not forgetting the square root. Ooh. Okay, so I know what a is. A is 2, so 5 minus 2, that will be 3 squared. And I know what b is. B is 3, so 7 minus 3, that is 4. So that's 4 squared. Okay, this is a nice number. 3 squared is 9, 4 squared is 16, so we get 25 if we add the 2. And therefore our radius is 5 units. Alright, they didn't give us any units now. Yeah, so that is the radius of the circle. Yes, the radius of the circle. That is the length of the radius. And then 4.2.2, it says calculate the length of TR. So T is the x-intercept of the circle. Guys, to get the equation of a circle, you need a center and you need the radius. So we can actually write down the equation of the circle, which would be x minus 2 squared plus y minus 3 squared, and that is equal to 5 squared. So if I were to get the x-intercept, I make y 0. So x minus 2 squared, and then I have 0 there, minus 3, so I have minus 3 squared, and that is equal to 5 squared. Alright, so let us multiply out x minus 2 squared. So that will be x squared minus 4x plus 4, and then we have a 9, and we have 25 over there. So I'm going to bring 25 to the left side. So I have x squared minus 4x, and then if I take 4 plus 9, that's 13. But let's just write everything as is. And I get negative 12. Okay. So that's negative 12. And then I ask myself, I am not going to use the quadratic formula. I feel like that will take time, but I'll look at the factors of 12. What will give me negative 4? Alright, so factors of 12, we have 1 and 12. We have 2 and 6, we have 3 and 4. So 2 and 6 are the candidates of giving me 4. So if I have negative 6 plus 2, it will result in negative 4. So that is great. So I have 2, I have 6, negative 6, and positive 2 will give me negative 4. And then I have that x is minus 2. Right, I suppose that's where t is, right? So t is negative 2 and 0, or x is equal to 6. That's basically r, right? Yeah, that's r. It's a nice way of checking that you got the correct answer. But they were looking for the distance, nah? Or the length of TR. So because TR are both lying on the x-axis, I don't have to use the distance formula. I can just say that TR is basically 6 minus 2, and that will be equal to 8 units. Alrighty. Okay, so that's 4.2.2, and then we get to 4.3. Alright. So determine the equation of the tangent to the circle at K. Okay, so if I want the equation of the tangent written in the form y is equal to mx plus c, I need a gradient and I need a point. A point is not a problem, we have K. The gradient is what we need to now calculate for, because the radius is always perpendicular to a tangent line. If I have the gradient of the radius mk, okay, not mr, so basically, yeah, no, let me not get ideas. So I'm going to take mk and look for the gradient there, because I know that the gradient of mk multiplied by the gradient of the tangent line has to give me negative 1. So let's first start by getting the gradient of mk. Okay, so the y values, I have 7 for k. Let me just write out the equation. So yk minus ym all over xk minus xm. Okay, the y value for k is 7. The y value for m is 3. It is, yeah. And the x value for k is 5. The y value for m, the x value for m is 2. Okay, so I have 4 over 3. Okay, so if I have 4 over 3, what would the gradient of k be? Okay, so I know the gradient of k minus multiplied by the gradient of mk should give me negative 1. So mk would be equal to negative 1 divided by 4 over 3, which is the same as negative 1, times 3 over 4, Therefore, it is negative 3 over 4. Some of you can just look at it straight, or okay, I have a fraction, I'm going to just swap it around, put a negative to it. But for those who don't know where it comes from, I've taken the time to show you. Alright, so we have a gradient now. For the tangent line, we have a point. So we're going to use the equation y is equal to mx plus c. Okay, our gradient is negative 3 over 4. Our x value is 5. Our y value is 7. And now we can get what the value of c is. So c will be 7 plus 15 over 4. Okay, so let us see what is that going to amount to. So 7 plus 15 over 4, 15 over 4, that's 10,75. Okay, so I like using decimals sometimes, other times I prefer fractions. So I'm just gonna, I think for this case I will use fractions. So the equation of the tangent will finally be y is equal to negative 3 over 4x plus. And is it really a plus? Yes, it is a plus, because your tangent line will cross the y-axis somewhere there, 10,75, okay? So we have 43 over 4, and that is your equation. All right, and now 4.4, we're almost there. So a horizontal line is drawn as a tangent to the circle at M. Okay, if you have a circle and if you have a horizontal line, it can either be, let me just do this rather. Okay, so if we have a circle, okay, and we want to draw a tangent line, a horizontal tangent line, it could either be here on top or there at the bottom. Okay, so which one are they talking about? So now, a horizontal line is drawn as a tangent to the circle M at the point N. So where is N? Is it on top or is it at the bottom? But now they tell us the y value, D, is smaller than 0. If you look at our circle over here, if the y value is less than 0, it means it's negative. So we are looking at the horizontal tangent at the bottom. And at that point, that is where we have N. Okay, so yeah, we are basically looking at this point over here, which is N. This one does not qualify. Okay, what are they saying about N? Write down the coordinates of N. Okay, so we know that our center M is 2 and 3, right? N will have the same x value, which is 2. But what would the y value be, or what will the y value be? I know that the radius, right, because we have determined it on before, okay? So I know that the radius is equal to 5 units. So I know this is also 5 units. And therefore, if I want to know what the y value for N is, I'm going to say 3 and subtract 5. Okay, so 3 minus 5 is going to give me negative 2. And that is how I get the y coordinate of N. Alright, so I hope that was simple enough, and that was just 2 marks. And then 4.4.2. It says determine the equation of the circle centered at N and passing through T. Okay, so now we have a circle centered at N passing through T. So the circle is going to probably look, I don't know, maybe something like that. Yeah, something of that sort. Okay, and if that is the case and T is on the circle, what do they want? They want us to determine the equation of that circle. Okay, so I know the center because, like we said, you would have to get the center. If you want an equation of a circle, get the center and get the radius. So one thing we're not sure about is the radius. So we will have to substitute the values of t, okay, into the equation so that we can get the radius, and this is what I mean. So I have the center, so it's going to be x minus 2 squared plus y plus 2, because that's minus 2 squared, and that will be r squared. So what am I going to do? I'm going to substitute t. Now I forgot what t is. T is negative 2, ne? Yeah. I forgot. Where did I put t? Yes, t is negative 2. So my x value, I'm just going to say t is negative 2 and 0. Therefore, I have negative 2 squared, and I have 0 plus 2 squared, and that's r squared. So I have negative 4 squared, that is 16, 2 squared, that is 4, and r squared. So basically r squared is 20 units squared. I'm just going to say 20. Okay, so I do have my radius squared. If you wanted to know what the radius is, this is basically root 20, and it will be a positive root 20 because you can't have a negative value of a radius. But they're asking for the equation of the circle, so we're cool now. X minus 2 squared plus y plus 2 squared is equal to r squared, which is 20. So that's basically the equation, and we're done. So I hope you enjoyed this. I hope you learned something. Please spread the word, like the video, subscribe to our channel. Thank you for tuning in. See you guys. Question 5. Hello again. Welcome back to MV Tutors. Soon and I'll be looking at question 5 with you guys. You know the drill. Like and subscribe. We'll get to the question now. So let me just remove myself there a bit. Yeah. Okay. So question 5. In the diagram below, we have P with the x coordinate of negative 7 and a y coordinate of 4. And it's a point in the Cartesian plane. Then R is a point on the positive x-axis, right? Such that we have an obtuse angle, which is theta. All right. Now it says, without using a calculator, we should calculate the length of OP. All right, so I am going to draw, so this is question 5. I'm going to draw the triangle that we have there. Okay. So basically, we have that big theta there. And then the x value is negative 7. The y value is 4. Okay, and if we were going to get the length of OP, so this is P and this is O. So to get the length of OP, I will then use Pythagoras. Okay, so OP squared would be 4 squared plus negative 7 squared. So therefore OP is root 16 plus 49. And what is 16 plus 49? They said we shouldn't use the calculator. Okay, so 6 plus 9 is 15. And then we have 4 plus 1 is 5. Plus 1 is 6. So we have root 65. Okay, we didn't use the calculator. I was about to go and take it out. But obviously in the test you can take it out. I mean, they won't know. But just don't write what root 65 is, or else you'll be exposing yourself. Alright, and then it says, calculate the value of tan theta. Okay, so how would I do this? I have an obtuse angle, né? And if I want to reduce this to an acute angle, in the second quadrant, I basically have 180 minus theta. Okay, and if that were to be tan, 180 minus theta, that's basically negative tan theta. Okay, so theta, I don't want to confuse you, but it's like theta is at this point now if I have reduced this big obtuse angle. Okay, so whatever answer I get, basically what I'm trying to get to is whatever answer that you get, you must have a negative value to it. And that would be easy because 7 is already negative. So tan would be the opposite, which is 4 over the adjacent, which is -7. I'm just going to put the negative that side. So yeah, that's basically that. And then we're looking for cos theta minus 180. Okay, so I'm not used to theta minus 180. I'm used to 180 minus theta. So how am I going to deal with it? I'm going to take the negative out. Okay, and I have 180 minus theta. And 180 minus theta is in the second quadrant, which makes cos negative in that quadrant. So basically, I have a negative and a negative cos theta. Alright, so basically, I have cos theta. Wow, it took long to get there. But now, what is cos theta? Alright, so we have OP as root 65. Cos, basically, of theta would be adjacent over hypotenuse. So that's basically -7 over 65. And now we get to 5.2. So it says determine the general solution of sine x times cos x plus sine x and da 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 da. Alright, so whenever you calculate or you determine the general solution, you need to end up with either sine, cos, or tan. You can't have two of them in there. It just won't work out. Okay, so we have sine x times cos x plus sine x being equal to 3 cos squared x plus 3 cos x. So as I'm writing this down, I can see that I have, I can factor here. I have a common factor on both sides. So on the left hand side, I have sine x as my common factor. So therefore, I'm left with cos x plus 1. And then on the right hand side, I have 3 cos x as my common factor. So I'll be left with cos x plus 1. And I can divide both sides by cos x, so they will cancel. And I am left with sine x being equal to 3 cos x. Like I said, I can't have both sine x and cos x. So I remember my identity that tan is actually equal, or tan of an angle is actually equal to sine of an angle over cos of an angle. So I'm going to divide both sides by cos x so that I can get tan x, right? And so, what am I doing here? So basically, I have sine x over cos x, and I'm left with then tan x being equal to 3. And so how do I get my reference angle, which is x? X would be inverse of tan 3. And what would that value be? Shift tan and 3. Okay, so that is basically 71.57 degrees. 71.57 degrees. No? Yeah. So that is my reference angle. I'm halfway through. I need to get the general solution. Then I need to ask myself, in which quadrant is tan positive? So it's basically positive in the first and the second quadrant. Secondly, what is the period of tan? Because I know the period of sine and cos is 360, but the period of tan is 180 degrees. Okay, so if I then get my general solution, so now I'm looking at the first quadrant. Okay, so that's basically going to be x is equal to the reference angle, which is 71.57 plus 180 times k, where k is an element of integer. Alright, and that's it. We're done with getting the general solution for the first quadrant. we need to also get the general solution for the third quadrant. And in the third quadrant, we know that is where we have 180 plus. So here we have 180 minus theta. This is 180 plus theta. And this is 360 minus theta. So 180 plus theta. So x is equal to 180 plus 71,57 plus 180 times k, where k is an element of integers. Guys, you need to write that down. K has to be an element of integer. Okay, you can't have k being a fraction. So you need to state it, or else you lose marks, or a mark. Okay. So what is 180 plus 71,57? It will be 251,57. Okay, 251,57 plus 180 times k. You don't have to write k as an element of integer. Again, as long as you wrote it in the first row, you're good to go. And that is that in terms of getting the general solution. So we can move on to 5.3. Alright, so it says, given the identity, 5.3.1 says, prove the identity given above. For me, I like proving that the left-hand side is equal to the right-hand side. So let's attempt that. So left-hand side, we have sine 3x all over 1 minus cos 3x. Okay. So how are we going to make the left-hand side equal to the right-hand side? Basically, first of all, I want sine x to be, or rather sine 3x to be in the denominator, right? Somehow. Right, and then I want 1 plus cos 3x to be in the numerator. So here's what I'm thinking. Remembering the identities we have, if I can multiply both the numerator and the denominator by sine 3x, in the numerator I'll have sine squared 3x, and I can do certain things, I think. Let's just multiply by sine 3x over sine 3x, which is the same as multiplying by 1. Okay, so if we do that, I will get sine squared 3x in the numerator, and then I would have sine 3x times 1 minus cos 3x in the denominator. So if I have sine squared, I'm thinking of my identity where sine squared x plus, or sine squared of an angle plus cos squared of an angle is equal to 1. Okay, so I can transform the sine squared into 1 minus cos squared 3x. Okay, is it starting to form shape now? I hope you see it. Cos 3x. Okay. So now I have a difference of 2 squares in my numerator, and if we have that, we can write it out. So I have 1 plus and I have 1 minus. So I have cos 3x, cos 3x. Okay, so you can see what's going to cancel, and things are starting to make some sense. Cos 3x. So I can cancel out this over here and that, and then I'm left with 1 plus cos 3x all over sine 3x, and that is basically equal to the right hand side, and we have proved the identity. Okay, and then 5.3.2, the last question, it says determine the values of x in the interval where the domain is basically from 0 to 60, for which the identity will be undefined. Okay, if you're going to look at the left hand side, if it will be undefined, it means your denominator has to be 0. Okay, so basically that's where you're saying 1 minus cos 3x is equal to 0. Okay, if you're looking at the right hand side, Again, the denominator, if this sum were to be undefined, the denominator has to be equal to 0. So you would take sine 3x equal to 0. And you can take either of them, it doesn't matter. We know that they are equal. Okay, I'm just showing you that both of them actually do work. Okay, and if you were to solve for your reference angle here, so you'd have cos 3x is equal to -1, negative cos 3x, and then I would have that 3x is equal to cos inverse of cos 1. And you know, if you imagine the cos graph in your mind, it's 0. I feel like I'm not making sense. The cos function is like this. Okay, so at that point where x is 0 on the y-axis, that is where you have 1. Okay, so in this case your reference angle will be 0 degrees. I mean, even if you take 3x divided by 0, you're still going to get 0. So ultimately your angle is going to be 0 degrees. Okay, if you were to take sine to the other side, okay, you have 3x is equal to the inverse of sine. You know that the graph of sine is like this. Okay, so the y-intercept, which is also the x-intercept, at that point, or the origin, you have that the angle is 0. Okay, 0 degrees basically. Okay, so that would be your solution. Determine the values of x in that interval. You can't get anything else. I mean, even if you go and determine the general solution, your reference angle is 0. If you're going to take cos for 1, your reference angle will be 0 for the first quadrant. And in the fourth quadrant, where you have 360 minus 0 plus 360 times k, where k is an element of integer, you're still going to get 0. You're not going to get anything within that range of 0 and 60. Yeah, it's just going to be 0. If you had a bigger range, then yes, probably you would get something there, because you were going to probably divide your everything. My hell. Basically, if maybe we took sine, for example, and we're looking at the second quadrant, it would have been 180 minus 0 plus 360 times k, where k is an element of integer. Okay, so if we had a bigger range, if maybe x was the domain was between negative 360 and 360, yes, you would get more answers. But because now the range has been, or rather the domain has been limited to 0 and 60, you can't get anything but 0. Okay, so what do I mean? If we were to divide by 3, I would get 180 divided by 3, that's 60. That'll be 120 times k. So there already, actually, oh, I can actually, wow, there's the solution. If basically k was equal to 0, wow, okay, if I didn't do this, I wouldn't have known. If k is equal to 0, then x is 60. Okay, so 0 is not the only option, guys. We have, wow, so we have x is equal to 60, and we also have that x is equal to 0, if you got the general solution. I'm glad I did this. Okay, let me see, what else? Yeah, so that's basically in the second quadrant, because in the first quadrant you would have gotten that x is 0 in any case. And yeah, there's no other solution. It's just going to be 0 and 60. I'm glad I did this. I was honestly going to leave it here, but just to be safe, determine the general solution, just so that you can see for yourself that indeed you are going to get one answer or two answers or whatever, just to be safe. Okay, these 3 marks are worth it. And with that, that is question 5. Yeah, see you next time. Question 6, maybe it's me, maybe it's my husband, who knows. But enjoy the rest of your day, night, evening, afternoon, whenever you watch this. I hope you are blessed by this and you can do this by yourself. All right. Hello again and welcome back to NV Tutors. I'm Tolo and we'll be looking at question 6. So I am back. I thought I was going to call it a night, but let us keep going. Alright, so 6.1. Without using a calculator, simplify the following expression to a single trigonometric term. Okay, I know for some people it is yakalala, but guys, please, you really can do it, okay? You can. Say yes, I can. This is not so difficult. I actually prefer these questions over Euclidean sometimes because Euclidean can get a little bit tricky. You need to turn your paper many times and see what's happening. But even with that section, there's a trick to it. Okay, so let's see, what can we do? Sine 10, well, it's already in its acute angle form, so I'm not going to do anything to it. It's not a special angle either. Then we get to cos 440, and you're like, what the hell? Well, do not panic. In a case like this, so if I were to draw a Cartesian plane, okay, we know that we start at 0 degrees, then we go to 90, and then 180. So it's basically in steps of 90, right? 270, 360, okay? Now, if you have a value or an angle that is above 360, please continue adding the 90s. So 360 plus 90, that will give you 450. Okay, 450. 450 plus 90 will give you 540. 540 goes 630, and then you have 720. Okay, so it doesn't matter how big the angle they give you, just keep adding 9s, okay, or 90s in this case, and then you can see in which quadrant you're working with. So 440, it's actually in the first quadrant. And so what do you do to figure out what the angle is? You're basically just going to take 440 and subtract 360 so that you can determine what the angle is, and that is 80. Okay, so cos 440 is basically the same as saying cos 80 degrees. Okay, yeah, and then we have tan 360 minus 0. That's basically in the fourth quadrant, and we know that tan is negative in that quadrant. Alright, and then we have sine 2 theta. Ooh, that's a nice one because there's only one solution if you have a double angle of sine. If it was a double angle of cos, we're going to have to wonder which of the three options would be or would work. Okay, so when we get to sine 10, we have cos 80. I want you guys to realize here that 10 degrees plus 80 degrees is actually 90. Remember, sine and cos are actually complements of one another. All right, so if you were to go and check on the calculator, what is sine 10 degrees? Okay, it is 0.17. If you go and check cos 80, it's also going to be the same, 0.17. And therefore the two are equal. Okay, but if you wanted to show it in calculation form, you would then say, remember your co-ratios, you would say sine 90 minus 80 is what gives you 10, right? And then you have cos 80 there in the denominator. And then this tan, I am going to change it to sine over cos. Because what am I going to do with tan by itself? And then I still have 2 sine theta cos theta. Alright, so the sine and the 90 change to cos, okay? And what I'll be left with basically is the angle 80. It's like when you were doing your co-ratios and you had sine 90 minus theta, sine 90 plus theta, and we just determine what the values are. You could do that easily, right? But now we have values. Don't think too much about it. It's the same thing. Sine 90 minus theta basically would be cos theta. Okay, so the angle, same angle. So even here, cos 80. I hope you get that. But moving right along. So we have cos 80 over cos 80. And then we have sine. Okay, so the cos and that cos can basically cancel. Then I have 2 sine squared theta. Alright. And then here I have 1, right? Because cos 80 over 80 is 1, plus 2 sine squared theta. And no. There was a negative here. Ooh. All of this should be negative because now I'm thinking, am I really done? Okay, so this is supposed to be negative, and even here, negative 1 minus. So I realized that 1 minus 2 sine squared theta is a double angle of cos. So at the end of the day, I have cos 2 theta. Alright, and that is 6, 1 completed. Now we have 6, 2. So it says given, we have sine, and then 60 plus 2x and 60 minus 2x. Alright, so it says for 6.2.1, calculate the value of k if that whole expression is equal to k times cos 2x. Alright, so let us write that expression down. So we have sine 60 plus 2x plus sine 60 minus 2x, and that is all equal to k cos 2x. So basically going to remove the brackets, okay, and just multiply it out. Alright, so I know if I have sine over here, it'll be sine cos cos sine. If it was a cos situation, it would be cos cos sine sine. Alright, so sine 60 times cos 2x plus cos 60 times sine 2x. Alright, and then I have plus sine 60 cos 2x minus cos 60 sine 2x, and that is all equal to k times cos 2x. Alright, so sine 60, they didn't say anything about not using a calculator, but it's a special angle, so sine 60 is basically root 3 over 2. Alright, and then cos 2x, well, it is what it is. Actually, before I even put down the values, let me just see what's happening. So I have sine 60 plus cos times cos 2x. I also have sine 60 and cos 2x, so I can add those two. Then I have cos 60 sine 2x, and I have minus cos 60 sine 2x, so I can definitely remove those. Okay, that makes life a little bit simple. So I have 2 sine 60 cos 2x, and that will be equal to k cos 2x. So things are starting to come together here. And then sine 60, like I said, is a special angle. It's basically root 3 over 2, and I'm gonna leave cos 2x as it is. So if I just simplify things, this is like 2 over 1, so I'm gonna just cancel. I'm left with root 3 cos 2x k cos 2x. I can basically cancel that out, and now I have that k is equal to root 3. Alright, so we have the value of k. Okay, now we're going to look at 6.2.2. So they say if cos x is equal to root t, without using a calculator, determine the value of tan 60 and all of that in terms of t. Okay, so what I want us to realize, basically we have tan 60 here. It's a special angle, and I honestly forgot what that is, truth be told. But then in the previous sum, we did solve for all of this, basically, and we found that it is root 3 cos 2x. So that is basically what I'm going to put there. I'm not going to put the whole sine 60 blah blah blah. That's going to take forever. I mean, this is what, 3 marks, so we shouldn't be laboring that much. Okay, so yeah, tan 60. So in a case where you have me who has forgotten, you can either do it the long way by saying sine 60 over cos 60, because I know what cos 60 is a half. I know what sine 60 is, it's root 3 over 2, and that will just be equal to root 3. So let's see, if we were to just put in tan 60, the teachers don't have to know that we don't know. So that's basically root 3, right? It's a special angle, like I said, you should know it. So I have root 3 here, okay? And I also have root 3 there. Cos 2x, it's a double angle of cos. There are 3 options available. I am not going to take the option where I have sine in it. So that leaves me with one option, okay? That's basically going to be 2 cos squared x plus, minus 1. By the way, this is available in the formula sheet. I am just going with memory here. So if I make a stupid error, yeah, that will be the end of me. So I have 2, and this is, if you have cos squared x, it's the same as saying cos x, and then you square it over there. Okay, that's okay. So if I have root 3 times root 3, that will just be root 9, which is just basically 3. But I have 2, and I already know that cos x is actually root t. So I have root t squared, and we have minus 1 over there. So I have 3 here. Actually, yes, double bracket. I have 3 times 2, and in a bracket the square root and the exponent 2 are going to cancel each other, so I'll be left with t minus 1. So then I have 6 times, you know what, let me just keep this 2 where it is for now. Ne? Let's just keep that where it is. So I have 2t minus, hey, because once we take brackets out, the answers are not going to be the same anymore. So let's start first by removing the brackets, and then we can multiply. BODMAS. So we have 6t minus 6. Yeah, it was going to work out the same. But yeah. No. What am I saying? Yeah. No, actually. No. Yo, guys. You see now when brackets go wrong. Okay, so I had this t in brackets, right? And I had a minus 1 there. So basically, I'm talking about BODMAS, and BODMAS is busy chowing me. So I have 2t minus 1. Okay, yeah, because these 2 are multiplied first, and then there's that negative 1, right? Then we can multiply the 3 in. So we have 6t minus 3, and we can call it a day. Bye. Hello everyone, and welcome to MV Tutors. I'm Tsulu, and we'll be looking at question 7, alright, the trig graphs. Some people can tend to be intimidated by it, but once you know the graphs and you've practiced and you've used that website I once referred to you for paper 1, Desmos, you can actually plot the stuff, take it up, down, left, right, see how the changes actually affect the graph. I would advise you to do that, especially for those who are writing in November. Okay, so yeah, we have the graph of f of x, which is half cos x, meaning your amplitude has been halved. And then we have g of x, where the sine graph has been shifted 30 degrees to the right. So if it's negative 30, it has been shifted to the right. If it's positive 30, it's shifted to the left. Okay, they are drawn in that interval. The domain is from negative 90 to 240. And then A and B are the y-intercepts of f and g respectively. Okay, that's good to know. Now 7.1, determine the length of AB. So since we've been told that they are the y-intercepts, when you want to determine what the y-intercept is, you put x as 0. Okay, so if I put 0 degrees there for f, I have a half cos 0. Now, cos 0 degrees is 1. Okay, I hope you know that. So if it is 1, it means I have a half times 1, which is just basically a half. With g, substituting 0 degrees there, I would have sine 0 minus 30. 0 degrees minus 30 degrees, and that's basically, we have a negative angle. And what do we do with negative angles for sine? We basically take the negative out. Okay, if you had a negative value for cos, remember negative angles for cos is just going to be equal to the positive angle, but with sine and tan, you're going to get negative values. So that's negative sine 30, and we know that sine 30 is a half, so it's basically negative a half. And for, okay, this is basically, yeah, so basically A, the y value is a half, and B, okay, I'm going about this the long way. You could have easily seen this and written the answer, so please don't mind me. So if I want AB finally, okay, it'll basically be a half minus a half, which is basically 1 unit. Okay, then 7.2, it says write down the range of 3 times f of x plus 2. Okay, so 3 times f of x. What is f of x? F of x is a half cos x. Okay, and we are adding 2. So basically, your amplitude has been magnified by 3. Okay, so if you had a half, this is a half, right? And now you have amplified it by 3. So that'll be, what's a half times 3? It's 1.5. So basically, you're going to be somewhere here. 1.5. Let me just say 3 over 2. Yeah. And here on the other side, if this was a half or negative a half, you would end up being somewhere here, negative 3 over 2, right? So yeah, this is basically how your graph would amplify in terms of the amplitude. Now you add that, 2 units up. So if I have 1.5, I like decimals in this case. So if I have 1.5 plus 2, it's going to end up being 3.5. And if I have negative 1.5 plus 2, that's basically going to be 0.5, positive 0.5. So then I know my graph, my minimum is at, okay, so I'll have my max somewhere there, and I'll have my minimum somewhere there. So my minimum is 0.5, my maximum is 3.5, and that's basically my range from 0.5 to 3.5. Okay, but I'm going to show you how else to write it. So from 0.5 0.5 to 3.5. But yeah, let me just show you how else you can do it. Okay, I decided to write this in the meantime. So another way to do it is to say, I'm going to use the formula. I'm not going to use the sketch because I might get confused and I don't know what's happening. So they told you that the amplitude was multiplied by 3 and you added 2 units up, right? You moved the graph it shifted 2 units positively vertical. So what you can do, you can use this equation and tell yourself where my y value is its max. Okay, so here we have a, that's the max, and there that's your minimum. What is the x value there? My x value there, where y is max, I actually have 0 degrees. My x value where this graph f is actually a minimum, that's actually 180 degrees. Okay, so I'm going to take this formula and just substitute x is equal to 0 degrees for y max and x is equal to 180 degrees for y minimum. Alright, so basically 3 times half cos 0 degrees plus 2, and I'm plugging it straight in the calculator. And here I have 3 half cos 180 degrees plus 2. Yeah, so I have a half times cos 0 plus 2. Okay, and that is okay, multiply, so this is bracket plus 2. Did I put this correctly? Yes, brackets are important. So I have that value is 3.5. Okay, that's my max, 3.5. And then if I just put 180 there, okay, 180, that's basically going to be 0.5. Okay, so that's how you could determine this algebraically, okay, by using the formulas. And I know that my y value is in between 0.5 and 3.5. Okay, so that is 7.2. I took quite a while, but I hope you understand. Now it says read off from the graph a value of x for which g minus f is equal to root 3 over 2. So g minus f is equal to root 3 over 2. So if I'm going to use the graph, I need to ask myself, what value is root 3 over 2 exactly? Okay, because I don't know. So root 3 over 2 is actually 0.87. Okay, so this is actually 0.87. So what I would do, I would go to the graph and try to see where do I have a space of like 1, okay, and then something that looks like 0.87. Okay, so if I know the space between A and B, I calculated it, that is 1. Okay, if I go to the left, yes, sorry, to the right, not to the left. Oh, by the way, for those who don't understand, when they say g of x minus f of x, what do they mean? Basically, they're saying, look at the y values for g. So y values for g, and look at the y values for f. Okay, take g, wherever you have g, and you subtract f, the y values of g, and you subtract the y values of f, where is it going to give you 0.87? Okay, so we're basically going to look at where g is actually higher than f. And g is the sine graph, né? Which is this one. So this is g. So in this portion over here, we're not even going to look at anything this side. Okay, we're not looking anything that way, because there f is actually bigger than g. We're gonna look pretty much this side, in this region over here, and we're gonna look at something that can give you 0.87 basically, and then we're gonna test it. I know they didn't say anything about using the calculator, so we can check. All right, so if I look at 60 degrees, this is definitely not going to be 0.87. If I look at 90, it's not 1. I mean, 1 is there, right? So this looks like a good candidate. All right. If we look at 120, I mean, if this is already 120 can't work out because it goes further than that. 150 as well, I don't think it would work out. It goes further than that. Yeah, this is big. This is really big. If we look at 180, I don't know. I mean, it looks promising. Yeah, 180 and 90 look promising. But let us see. Let us actually plug the values and see. Okay. Whew. Long equation, but let's do it. Okay. So it's G minus F, right? So G, I have sine. So I'm saying 90 minus 30. And then I'm subtracting a half cos 90. Okay, yeah, so 90 works. Let's see if 180 would work. 180. No, that will give you a straight up 1. Okay, so 90 works, 180 does not work. It gives you exactly 1. Maybe something, no, 210. Yeah, I feel like there's another solution somewhere here, to be honest. And because they said look at the graph, how many marks is this? It's just 2 marks. If I would have time, I would literally write out the equation and actually solve it so that I know I have all the values. But I feel like there must be something. If I were to take 190, maybe let's see if we would get to the close to the answer. We're getting there, you see, so who knows? So there is another solution there. But because they said look at the graph, yeah, so it's somewhere by 180 something. Let's see, 185. Out of interest. 185. Nah. And that is a 180, it's 1, eh? Yeah, so it's somewhere also in between 180 and 185. Yeah, 180 and 185. The solution. 180, maybe 170. Yo, okay. Anyway, in the test, you won't have time to really do this. Yeah, you really won't. So you'll just, the safest one to go with is 90. But the solution really lies in between 185 and 190. I'm gonna put it there. Yeah, 185 and 190. Yo, look at me wasting your time. Okay, guys, you can go to the next question. Almost there. But basically 185 and 190. There lies your solution. So basically what values of x will give you that? It is basically where x is equal to 90 degrees. And x is somewhere in between 185 and 90. But here they would know that, yeah, this one needs the calculator. But they didn't say anything about the calculator. No, they didn't. Okay, so 7.4, for which values of x in the interval of negative 90 and 240 will f of x, the y values of f, times the y values of g be bigger than 0? If it's bigger than 0, it means that it is positive, right? So a positive times a positive will give me a positive. A negative times a negative will also give me a positive. So I'm looking for values where both are positives, okay, and in both are negatives, and we can see what we do with that solution. Okay, so let us attempt this. So in this region here, where negative 90 is, I have positive values for f, and negative. Okay, let me just do this. I have positive, positive, positive. I think maybe this will be easy. Yeah, it's laborious, but it is practical. You can actually see for yourself what is actually happening. Okay, so from negative 90 up until 0, our solution is definitely not bigger than 0 because we have positive and a negative. Okay, so a positive times a negative will definitely, so this is not what we're looking for. So from here, we don't have a solution. Actually, let's say from this point where they intersect, we don't have a solution. Okay, no, I'm lying. Up until 30 degrees, we don't have a solution because you have positive values for F and negative values for G. But when you get to 30, you have 0, okay, for G, and you have positive for F. So our solution actually starts there by 30 degrees, but we don't include 30 degrees because they didn't say it should be equal to 0. They said it should be bigger than 0. And then from 30 degrees up until 90, we have positives. You see that? But 90 is not included, or else you get a 0. And then as you move on, so from 90 up until 210, there's still no solution because you have positive and you have negative. But from 210, let me say and. From 210, no. From 210 all the way to, because you have negatives here. Well, our domain is limited to 240. So from 210 to 214, you also have a solution. Okay, so you could have written it as x is an element of 30 up until 90, and then include 210 up until 240. All right, and then that is 7.4.1. Now 7.4.2. I need to rush. I have a tutorial session after this. So again, find the values of x in the interval where g prime x minus 5 degrees is bigger than 0. Okay, so basically what is happening here? You have shifted the graph of g 5 units again to the right. Okay. Trying to erase this. So instead of having sine x minus 30, you're actually going to have sine x minus 35. Okay, because the whole graph has shifted 5 units again to the right. Did I say left the other time? Sorry. To the right. Okay, so instead of it passing, this is the graph of G. No? We're looking at G now. So instead of it now being at 30, it's now going to shift to what? 35, because it's shifted to the right. Instead of 90, it's going to be negative 85. Okay? No, I'm looking at the wrong graph. Okay, sorry about that. So, yeah, instead of 210, yes, this is the correct one. We're going to move now to 215. Okay, this is very exaggerated. So, yeah, that is basically that. And then, but now, the trick here is it is G prime, meaning this is the gradient of G. Okay, the gradient of G. And that makes a huge difference. We're not looking at how the graph has shifted 5 units and then what happens now. No, we want to know, yes, the graph has shifted 5 units to the right, but what is actually happening to the gradient? Okay, because we need to have a positive gradient. If I go from 90 up until 60, I have a negative gradient, because I'm going down. From negative 60 up until 120, I have a positive gradient, which is what we're looking for. And then from 120 to 240, we have a negative gradient. But remember, this graph has shifted 5 units now to the right. So this, instead of negative 60, will be negative 55. Okay. And then instead of 120, we're going to have 125. But remember the turning points, that's where your gradient is 0. Okay. Hence, whenever you get the first derivative, if they want in a cubic function, the turning points, you would make the first derivative equal to 0 because those are your turning points. The gradient is 0 at that point. So even here, we're not going to include negative 55 degrees and 125 degrees because those are your maximum and minimum. Those are your points where your gradient is 0. Okay, so here gradient is 0, gradient is 0, here gradient is bigger than 0, gradient is less than 0, gradient is less than 0. Okay, so they're looking for the gradient, so just be careful. Do not ignore this prime over there. It makes a huge difference, and this is basically where your solution lies. All right, so we are done with question 7. Thank you for tuning in. Hello everyone and welcome to MV Tutors. I'm Tolo and I'll be looking at question 8 with you guys. So let's get right into it. And you know the drill. Please don't forget to like our videos as well as subscribe to our channel. Please share this information with fellow matrics and also with those who are upgrading. All right. Okay. So question 8. It says figure 1 shows a ramp leading to the entrance of a building. B, C, and D lie on the same horizontal plane. The perpendicular height AC of the ramp is 0.5 meters and the angle of elevation from B to A is 15 degrees. Okay, we can see it is sketched over there. The entrance of the building AE is 0.915 meters wide. Okay, so we can see a 3D figure for figure 1, and then figure 2 we can see the top view. Okay, now it says calculate the length of AB. Okay, so when we get to 3D trig, I like to draw the triangles separately so that we see what it is that we have. Okay, and we can see also when we look at the top view, if you look at triangle BFD, I know D is not showing at the moment, it was cut off when scanning this paper, but BF is the same length as FD, so we have an isosceles triangle there. But let's just draw the triangles that we have, that we know the information to, and see where that gets us. Okay, so we have a right angle triangle. Actually, let me do this. Okay, we have a right angle triangle. Okay, so it is A, B, and C. Okay, so that is 0.5 meters. And yeah, we have 15 degrees there. Okay, and then I also said, I'm just gonna, okay, let me leave the other triangles. Maybe let me just draw all of them before we actually calculate length AB. Okay, so we have that first triangle, and then the second triangle I'm gonna look at is AE. You know what? No, you know what? Let's just answer the question. Let's answer question 8. If we ever need another triangle for information, we'll go to it. Okay, so 8.1. Calculate the length of AB. So basically this is the length. Okay, so we're going to use basic trig. Okay, so we have an opposite. If we use sine over there, we have opposite over hypotenuse, and hypotenuse is what we're looking for. So sine 15 degrees is equal to 0.5 over AB. Okay, so AB is actually equal to 0.5 over sine 15. And now we need the calculator. Let me upload it quickly. Okay, so I managed to get the calculator, and yeah, let's calculate away. So we have 0,5 divided by sine 15. Okay, and that's basically 1,93. Okay, if you round off to 2 decimal places, so AB is 1,93 meters. Okay, they gave us everything in meters, so let's stick to that. Alright, so 8.2, it says figure 2 shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles as shown in the diagram. So now BAE, the angle A in triangle BAE is equal to 120 degrees. So we need to calculate the length of BE. Alright, so if we're going to sketch this triangle, we have something like that. Okay, where we know that A is 120 degrees. Okay, we have E, and AE is 0,915 meters. And then we have B. We just worked out AB as 1,93 meters. And then what we're looking for is BE. Okay, so here what screams at me is the cos rule. Okay, so we're going to use the cos rule. What does the cos rule say? Well, BE squared is equal to AB squared plus AE squared minus 2AB times AE cos A. Okay, and then we're just gonna plug in everything that we know. Yeah, let me just switch on other lights. I look so dark. Okay, much better. All right, so what do we know? We know that AB is 1,93. So that's 1,93 squared. AE is 0,915 squared minus 2 times 1,93 times 0,915. At this point, I hope we didn't delete that answer in your calculator because we're going to use it as it is. And then multiplied by cos 120. Okay, and then, so to get BE, we're going to put all of that under a square root. And then let's see what we can do. Alright, so that was our answer. So basically we're going to say answer squared plus 0,915 squared. Okay, and then minus, no, it must still be in there. Okay, minus 2 times the answer times 0,915 times cos of 120. Okay, and we have an answer of 2,52 meters. Okay, 2,52. If they don't specify to how many decimals you should round off, just round off to 2 decimal places. Okay, so we have BE, a nice 3 marks. And then now the last question. Okay, we have, they say we should calculate the area of triangle BFD. Okay, if the angle F is 75 degrees, okay, and we know that BF is equal to FD, we have a nice isosceles triangle, all right, and also BF is 5 over 7 BE. So basically we're going to sketch this triangle, okay, just so that we can put the information that we know in. All right, it's fine, not the best triangle, but we'll work with what we have. All right, so we have F, which is 75 degrees, then we have B, and we have D. Okay, so if we were to work out these angles, they would be the same, but they're not asking us for that, so we're not going to work it out. But what we do know is that BF is 5 over 7 BE, and BE we calculated it before. Okay, so I have 5 over 7, 2,52, and since BF is equal to FD, it's also going to be 5 over 7, 2,52. And now they want the area, so we're going to use the area rule. All right. Okay, so the area of triangle BFD. All right, so what are we going to do? We're going to look at the formula sheet because I kind of forgot it. All right, and then what is the area rule? There it is. Okay, it's a bit blurry. No, it's coming. It's coming. Okay, so we have half AB. Okay, so in this case, it's going to be half BF times FD, and then times sine F. Okay, so we know half, and then BF, that's basically 5 over 7 times 2,52, and because FD also has the same value, I'm just going to square it there, and then we're going to say times sine 75. All right, let's just go back to our question. All right, so we are about to calculate the area, and then we are done. Short question. Okay, so we have 0,5 multiplied by 5 over 7. Okay, 5 over 7 times the answer that we had previously, and we square it, and then we say times sine 75. All right, so we get the area to be 1,56 meters squared, because everything has been in meters so far. So 1,56 meters squared, and we are done with this question. I hope you learned something, or you could verify whether you got the correct answers or not, but from me, it's goodbye.
Well, good day to you, and welcome to MV Tutors. My name is Viagashe Manana, and I will be giving you this paper. We are now on question number 9. This is paper 2 of 2022 May-June mathematics exam. Well, if this is what you're looking for, then you certainly came to the right place. Just stick around and we'll get right through it. Let's get right into it. So over here it says, let's just read, this is a Euclidean geometry question. As you can see, it says in the diagram DEFG is a cyclic quadrilateral. So what I want you to do at this point is go identify this GE, and there it is, GDEF. I think that's the quadrilateral. I mean, they're talking about DEFG. So DEFG, good. Okay, so what do we know about this cyclic quad? Well, there are certain laws that we must know about it. One of them is that opposite angles are supplementary, meaning they add up to 180 degrees when you add them. And also the second one we know is that an external angle of a cyclic quad is indeed equals to the internal opposite. Okay, so that 72 literally be equals to G1 and 2. That's just clues we're getting from the question above. Okay, and then it says DE is parallel GF. Okay, so I want us to go identify the DE and the GF so that we can see these parallel lines. So DE, there it is. So this line is parallel this one. That's GF right there, GF. And indeed, they did show us there that's the parallel. What do we know about parallel lines? Is that if you have, like, maybe say you take this line, we've got alternating angles right there, and also, but if you take this one here, then we got internal opposite angle, which are corresponding angles. Okay, right there. So there's basically just a number of laws associated with parallel lines that we can use in this particular question. Those are just clues we're getting from the actual question itself. And then DE is produced to R. What is that telling us? Well, basically all they're saying is that DER is a straight line. Okay, it's a straight line. Well, I don't have to show it, but if you're interested in seeing it, then there we go. DER is a straight line, meaning it's 180 degrees over there. Just keep it in mind. It's just a clue that they are giving us. Okay, it's produced to R, and then they say T is a point on the circle. Let's go look for T. Where is T? Okay, it's a point on the circle. All right, circumference. Okay, so if it's a point, that means then we can then establish that this angle is equals to this one because they're subtended from the same chord, which is EF. That same chord EF, or same segment as you prefer, is subtending these 2 points, so they are literally equal. Okay, so those are just clues that we are actually getting from the graph, the statements that were being given. E.g., FT and ET are drawn. Okay, so they're just alright, they are drawn, meaning they're joined. EG, I see EG. FT, where's FT? I see it. FT and ET, where's ET? I see them, they're drawn. Now they give us that E4 is 72 degrees. I see E4, okay, right over there. Alright, 72 degrees. What else? And G1 is 16. Where's G1? I see G1 over there. Okay, cool. We're all good. Now, those are just clues that we got from the statement. Now, whenever I do my Euclidean geometry questions, I always start with an acronym called Dr. Cape Town. So it's just a D, right, and an R for doctor, and then Cape Town is CPT. D stands for diameter, R radius, C cyclic quad, P parallel lines, and then T stands for tangent. Now, what I do with this is that I would go, do I have a diameter in this question? No, I don't. So I don't need any laws associated with diameters. Do I have a radius in this question? No, I do not. So none of those laws will matter. Do I have a cyclic quad? Yes. So I need all the laws associated with cyclic quad. Do I have parallel lines? Yes. I need all the laws associated with parallel lines. Do I have a tangent? No. So in this question, I'm only working with a cyclic quad and parallel lines. So there are no other laws that I'm going to be looking for to help me solve anything in this question except those for cyclic quads and parallel lines. So let's go look at the questions then. Alright, so it says determine with reason the size of the following angles. DGF. So where is DGF? It's DGF. Okay, I see DGF right there. DGF, so they want this whole angle right there. Okay, let me use a different color because I've been on this green tip. Let's go red. So DGF, that's the one. It's too big, I don't like it. Let me at least make it right over there. DGF. Okay, so remember we only have cyclic quad to help us and parallel line. So first of all, we'll start with cyclic quad. Will the cyclic quad help us to prove this? Let's see. Opposite angles, supplementary, is that helping us? Not really. It's not helping us with anything. The second law to explore then with cyclic quad is you know, the the angle, the outside angle being equals to the internal opposite. Okay, so if you don't see it, let me just make it more visible. There's our cyclic quad right there. Okay, I'm gonna draw it like that. Okay, there's an external line there, cyclic quad. Just do this. Okay, so there's our cyclic quad, and then what I was saying is that the outside angle or the external angle is equals to the internal opposite. So there we go. This was question 9.1, I believe. 9.11. 1.1. They say DGF. Okay, so I'm gonna say DGF is actually equals to 72 degrees. Oh, my bad. I forgot that there's a camera right there, so you don't really see my numbering, but that's fine. Let's just continue. It's equals to 72 degrees, and always write a reason. External angle of cyclic quad. Okay, I'll just put theorem. Okay, they are equal. All right, that's it for that question. See the next one. They want t. The next one they want us to solve t. Okay, first of all, let's identify t. Where is t? Let's go different color this time. Let's go green. I've been using green. Let's go dark blue. T is that angle there. And remember, when we're speaking about one of the clues, we can see, you can check this angle is subtended by EF, and another angle subtended by EF is G2. Okay, so first of all, what we can say here, let me just check. So it's 9.1.2. Let's change the color there. Let's go with blue. Good. So we're going 9.1.2. So first of all, we can say the angle T is equals to G2, and the reason is same chord. Now if you're gonna give or same segment, you're gonna give this reasoning, you need to also give the chord. What is the chord? EF. Same chord, EF. Right? Done. And then we can go solve for G2 now. What can we notice about G2? Okay, first of all, we know that this whole angle right there, we solved it, DGF, which is 72. So G2 will then be equals to 72 minus 16 degrees. Do you see that? We're gonna say 72 minus, let me just say G1. And then give a reason. What's the reason for this? It's a bit complicated, but I'm just gonna, it's not complicated, it's so easy. I'm just gonna say, because we calculated 72, I'm just gonna say calculated. Okay, as long as your reasoning makes sense. So it's 72 minus G1 is 16, and that's given So I'm gonna say and given, because the 16 was given. Now we need to put this in a calculator. Let's bring up a calculator. Ooh, where was I adding here? So I'm just gonna say 72 minus 16, and we get 56 degrees. That's G2. Then we can conclude then and say therefore T is equals to 56 degrees. There we go. That's it. Okay, 72 minus 16, that's G2, that's T. Good. Let's go to the next question then, which is 9.1.3. They want GEF this time. Let's look at GEF. Let's find GEF. Let's use a different color. What shall we do now? Let's go purple. GEF. They want this angle here, right there. Okay, what's gonna help us? Okay, I can visualize it, but let's write it down first. Even here, let's go purple. There we go. And that's question 9.1.3. So first of all, if we look at this, right, there's many ways we could really solve this question if we really look at it. But let's come back here. We haven't used our parallel lines, you know, so I would like us to use them this time. Okay, so take a look at this. I'm gonna draw those parallel lines. There they are. Oops, let's change the color. I want a different color. Let's go yellow. There's a parallel line there, and it's parallel to that one. Right? And let's do alternating angles right there. Now if you look at this, that angle there, G2, there, which is calculated, is alternate to E1. And if we have E1, let me just write it. G2, we solved it to be 56, which means E1 is also 56, right? Because that's 56 right there. So what? And then we were told that this is a straight line. Remember, the rules of a straight line is that they are equals to 180. So if we say 180, or basically E1 plus 2, 3, 4, that's equals to 180 because of straight line. But how are we going to do the write up? We're going to say, first of all, we're going to say E1 is equals to G2, and the reason is alternate angles. And when you say alternate angles, you always need to put the parallel lines. Now I prefer writing it exactly as they wrote it here. They said DE is parallel GF. Cool, that's it. And then we can go on and solve it. G2 is 56. That means E1 is equals to 56. Now let's just continue with that calculation. We're then going to say E1 plus E2 plus E3 plus E4 is equals to 180. And the reason is straight line. Okay, straight line theorem. Cool. Now we can go fill in the spots. What's E1? E1 is 56 plus what's E2? We do not know. That's what we are looking for. Actually, E2 is what we're looking for plus E3. That's what we're looking for. I just combined these ones, these two here. Just combine them to E2 plus E3. because that's what we're looking for. And then E4 is 72, and that's all equals to 180. Now if I'm gonna solve for E2 plus 3, it's gonna be equals to 180 minus 72 minus 56. Let's get our calculator. So we're gonna go 180 minus 72 minus 56. 52 again. Oh, not again. Okay, it's the first time it's being 52. 52. Okay, so therefore, what did they ask us for? GEF. I want to write it the way they wrote it for us. So it's GEF, which is, remember, this E is 2 plus 3 is equals to 52 degrees. Good. Always put your units at the end. Like you don't need to put units when you're solving it, but at the end, definitely degrees, because we're working with degrees here. As you can see, I put it all over. Okay, we're done with this section. Let's go to the next question. Here we go, 9.2. In the diagram, this diagram below, the diagonals of a parallelogram KLMN. So KLMN, this is a parallelogram. Okay, what do we know about a parallelogram? Well, there are a few things that we should know. First of all, the lines are parallel, so that one is parallel. The parallel lines are equal, right? Okay, so which means that also, so these lines are equal, number one. All right, number two, these ones are equal. These are just some clues we're getting from the statement. Okay, also what we do know about parallelograms is that they dissect each other, which means this line is equals to that one. You know, diagonals dissect each other. This one is equals to, you know, this one, this whole one. Okay, so that's what else we know about that. Okay, we're just getting clues. Intersect at P. Okay, they intersect at P there. So NM was NM down there is produced to S, which means it's a straight line. I see S down here. Good. And then furthermore, R is a point on KL. R on KL, I see it. And RS cuts PL at T. Where's T? There it is, I see it. Okay, so NM is to MS is 4 is to 1. Okay, let's find NM. NM is 4 is to 1. 4 is to 1 to MS. Okay, now whenever you write these ratios, these are not units, so you need to put a variable like X. Okay, those are just ratios. And then they say NL is 32 units. So N, let's just find L. NL, which probably ends there. Yeah, that's 32 units. And remember, they dissect each other, which means that remember we said that one there is that NP will then be equals to PL. Okay, so if they say it's 32, that means NP is 32 divided by 2, which is half of 32, so they're like 16 they're sharing. Okay, those are just some clues we're getting from this. And then TL is 12 units. Okay, they've even showed it here. TL is 12 units right there. Okay, so that's what we could gather from the statements. Now let's go read the questions and see what they require. But everything we're going to solve it based on these questions we've been given. Okay, let's start then with 9.2.1. Determine with reason the value of the ratio NP is to PT in simplest form. NP, let's find NP. So they want NP, which is that. I'm just going to use different colors. So NP is to what? PT. Okay, is to PT. Let's go green this time. Why? That's not what I wanted. But anyway, it's to PT. Okay, so what do we know? Okay, so let's look here. We're going to use what we've been told, the clues that we do know. First of all, we know that NP is 16, right? So we're going to say then NP is equals to 32 divided by 2. And the reason for this is because, remember, diagonals of a parallelogram bisect each other. Okay, bisect literally mean divide by 2. Okay, so NP is 16 then, because 36 divided by 2. Well, for those who are unbelievers, let's put it in a calculator. There we go, 16. And then now we need to solve PT, because we've established what that. So first of all, we're going to say PL. Okay, PL is equals to 16 as well. All right, and the reason is because same reason, diagonals of a parallelogram. Okay, and also PT then, PT is then going to be equals to PL minus TL. And one of the reasons is because TL is given, so I'm just going to go for given. Alright, PL is 16 minus TL we've been given is 12, which means PT then is 16 minus 12. I'm going to put it in a calculator because of unbelievers. It's 4. See? So now we can conclude then, therefore, we see that NP is to PT. NP we got what? NP we got 16, so we'll put 16 there. Is to PT. PT we put 4. And if we, sorry about that. If we further simplify, then we're going to get 4 is to 1. How did I get that? I divided both by 4. That's in its simplest form. That's our final answer. Because 4 divided by 4 is 1, and 16 divided by 4 is 4. Cool. Alright, we're done with that. Let's go to the next question. Thank you. What do they want? It says prove with reason that KM is parallel RS. Okay, let's look at this. KM. Okay, so KM is this big one here. Let me just illustrate it. That one is parallel RS. go, it's parallel RS. So they want us to prove that those are parallel. So what we're going to do here is that now if you remember, we were given that actually this ratio is 4:1, and then we just solved this one to be 4 units and 1 over there. Okay, so how we're going to write this up, we're going to say 9.2.2. let's change that to green. So we're going to go 9.2.2. we're going to say NP is to PT but let me put it this way. I want to put it a different way. Let me say rather than NP is to PT, let me say okay, it's fine, let's go PT is equals to 4:1, and this is did I solve? This has been solved. And then also here we have NM is to MS, NM is to MS is equals to 4:1. This is given. So since NP is to PT is equals to NM is to MS, therefore P, how did I write it? Therefore KM, it's not P over here, so I just need to go back. Therefore KM must be parallel to RS. There we go. That's it. We're done over there. Okay, let's check out the next question. Let me go back here just to clear the drawing. Okay, let's come look at this question now. It says if MN is 21 units, so NM is 21, determine with reason the length of RL. Let's find RL. RL is right over here. Okay, so given that, they want us to solve for that. What I can say therefore here is if you take a deeper look here. Okay, let's look at our parallel lines, right? We know that it's parallel 4:1 down here, but also what else do we know? We know that we have a, okay, let me write it down here. We actually have equal parts. You see what I mean just now. Let me change the color to blue. So this is now 9.2.3, is it? Let's see. Yeah. Okay, remember we have a parallelogram here, and in the parallelogram we know that KL and M, what's this one here, M N are equal. All right, do you see that? Which means that NM is equals to KL. That's there. So we're gonna say NM is equals to KL. L. Why? Because sides of a parallelogram are equal. Of a parallelogram are equal. Cool. Just gonna put it in short like that. Cool. And then furthermore, what we can say is, remember this side we solved PT to be the actual value, not the simplest one. The actual value, we solved PT to be 4 right over there. You see, PT we solved it to be 4. So we're gonna say PT is 4. Oh, my bad. Let me put the pencil. 4. So now we have 4 is to 12. Do you see that? Which means also the ratio here, since these are parallel, is 4 is to 12 as well, if I'm to put it in those terms like that. Okay, so when we come back here, what we're gonna say is that PT is equals to 4, and this has been solved, right? Now we can say the ratio PT is to T is to TL is equals to PT is 4, TL is 12. I need another page. Okay, there we go. I've got another page. So PT is 4 is to TL, which is 12. Okay, I can simplify this further if I want. So 4 divided by 4 is 1. 12 divided by 4 is 3. Okay, so essentially the ratio is 1 is to 3 between these two. And just remember this side, this is a ratio, it's not an actual amount, and it's actually 1 is to 3. Right, now if I know that this whole unit is actually is 21 units, KL is 21 units, right? Now if I want RL, I'm gonna use those ratios to solve for RL. But let's start here first. Watch this carefully. I'm gonna say PT is to TL is equals to KR is to RL, and the reason is proportional theorem. Proportional theorem, since I have these parallel lines. Okay, since I have, let me write the parallel lines. It's KP parallel RT. Okay, that's my reasoning. So therefore I can say PT is a ratio of 1 is to 3 as proven, so that's equals to KR is to RL. Now if you know your mathematical gymnastics, you will know that how to solve ratios, given a unit. So I'm gonna say 21. What did I just do? I want to say 21. 21 times, you see RL is actually the ratio of 3 divided by the addition of both of them. 3 plus 1 is 4. Okay, that is to get RL. Rn. Okay, using ratios. Now let's get the calculator. I said 21 times 3 divided by 4, and I get what? 63 over 4 as my final answer. In decimal, 15.75. That's my RL, and then I put units. Those are the actual units. Okay, let me just check, verify with the question. Did they say anything about decimals or simplest? Okay, so I'm just gonna leave my answer like that. Well, there it is. We did it. We finally reached the end of this question, and I hope you did understand. But if you didn't, well, we are available to tutor you. Just drop us a message under the comments, and we will get back to you. Other than that, well, please like and subscribe to this channel, so that other people can get access to this video. It really helps a lot. Then that's it from me. Enjoy the rest of your day. Goodbye. Well, hello there. Hello, my name is Philagasa Manana, and welcome to MV Tutors. Well, we are now doing the last question of paper 2 of May-June 2022 supplementary exam. So, if this is what you're looking for, let's get right into it. Okay, it says question 10. In the diagram, triangle ABC and DEF are drawn such that A is equals to D, B is equals to E. We see they're also marked over there, and C is equals to F. Okay, use the diagram in the answer book to prove the theorem which states that if two triangles are equiangular, then the corresponding sides are proportional, in proportion. So I need to prove that AB over DE is equals to AC over DF. Well, now our game plan here, what we have to do is take this triangle over here and try and put it in over there. Okay, that's our step number 1. And then once that small triangle is inside the big one, and then we can do the proportionality theorem, and then they will be equal indeed. Okay, but for now, let's try to put this inside there. Okay, so we are going to say construct. Okay, my bad, you can't see that. So what I'm going to do is that I'm going to how many times must I do this? Okay, I'm gonna say construct line MN. I'll call it MN. So I'll come this side. Okay, as our first step to construct line NM. So I'll just put a line over there like that. Okay, there's my line. And then I'll call it MN. Okay, so that's it. We've constructed our line. What we're trying to do is put this triangle this side. So then we are going to say such that AM is equals to DE. You see, AM is equals to DE. The reason is construction. Okay. Also, AN is equals to DF. Construction as well. Okay, and then the angle A is equals to the angle D that's given. The reason is it's given. So now we have a side and an angle to prove that these are congruent. Remember, congruence means equal sides, equal angles. So let's just write it in full. We can then conclude and say triangle AMN is actually congruent to triangle DEF. Okay, and it's due to side angle side or side angle, whichever you prefer. Now that we've proven that we've taken this triangle and put it there, now let's work with this big triangle. Okay, now we know that angle M, okay, angle E and angle B are equal, right? Let's just start there. Let's just say in triangle A, B, C and triangle A, M, N, but we really don't need to put it that way. Let's give each other more space. So we just want to work with this triangle. But first, let's just say angle M is equals to angle E. Congruency. And then also we know that angle E is equals to angle B, which is given. Okay, so if these two angles, that means that these two angles are equal, right? Because E is equals to M, right? Therefore, what does this tell us? This tells us that MN is parallel, the line MN is parallel the line BC, as we can see over there. You know, same angles, parallel lines. And this is because, what do we see? This is corresponding angles, rather. Corresponding angles due to corresponding angles. If these lines then are parallel, since they are parallel, it means we can do the proportional theorem. We can therefore say that A B over A M is equals to A C over N A N. Let's go back. Over A N. When it does this, over A N. See what we did? So big over small, big over small. Now that we've done that, but we know that AM is equals to DE, right? Okay, we've proven this. I'm just gonna say proven. And also, or proven or constructed, I can say AN is equals to DF. Okay, I'll say proven again. proved this. Therefore, we're gonna substitute where we have AM, we'll put DE. So AB over AM. AM. Okay, and that's gonna be did it again. I did that mistake again. I want to put, these things can get a little bit tricky. Let's see if it did it. No, it did not. Go back. Go back. Back. See now. Okay. So this should be a D. Let me go back once more. There we go. So where we have AM, I must put DE. Alright. AC stays. And then where I have AN, I must put DF. And that's it. That's exactly what we wanted to prove. Okay. Here I should have put this is due to the proportional theorem. Proportional theorem. Okay. That's it. Let's go to the next question. Here we go, question 10.2. In the diagram, O is the center of the circle passing through A, B, C, and D. So O, A, B, C, and D. So what does this tell us? O is the center. That's telling us a lot of things. Because O is the center, that means that line is a radius, that one is a radius, that one is a radius. Okay, and if you have two radiuses or radii, that means you have an isosceles triangle, which means that angle is equal to that one. Likewise, that angle is equal to that one. Okay, that's just the clue we get from O being a center. Okay, alright, let's just that. And then EC is a, where's EC? EC is a tangent, okay, to the circle at C, right there. So what does that tell us? The tangent rule, we know then that that angle there, then chord theorem would be equals to that angle over there. Okay, that's what we know, that's what that's telling us. Okay, and then diameter DB produced meets tangent EC at E. So diameter, what do we know about diameter is that it subtends a 90-degree angle. So that's 90 degree, and produced means it's a straight angle, a straight line, which gives us 180 degrees over there. Those are the clues that we're picking up from the statement. Okay, F is a point on EC such that BF is perpendicular to EC. So where's BF? BF is there, it's perpendicular to EC. Okay, I see. That's 90 degrees there. That means it's also 90 degrees over there. That's what that statement is telling us. Okay, radius CO produced bisects AD at G. CO produce bisects AD. Bisects means these angles then are equal, not angles, these sides. Okay, and that should be the case better because of the theorem of the center chord theorem. Alright, and then BC and CD are drawn. There's BC and CD are drawn. Cool. Now let's get to the questions. Okay, before we get to the questions, remember Dr. Cape Town. This will help. This is a system that helps you to solve Euclidean questions. So let's see, do we have a diameter? Yes, we have a diameter, so all rules associated with diameters are there. Do we have a radii? Yes, we have radii. We have cyclic quad in here. Well, not really. We have parallel lines. Not really. We have a tangent. Yes. Now this means that each and every question that we're going to do here will either require us solving it using um, diameter, a radius, or a tangent. So we're not going to look for any rules associated with cyclic quad or parallel line. Okay, so let's just put that into practice. 10.2.1a, it says prove with the reason that FB is parallel CG. FB is parallel, not parallel. Oh yeah, it is parallel CG. So they pretty much want us to prove that we got parallel lines. That one is parallel CG. That one. The only way we can prove is with you know, angles. If we can prove that this angle over here is actually, this one here is equals to that one. Okay, so let's do that really quickly. Let's say 10.2.1a. Okay, so we can safely say that the angle EFB is equals to 90 degrees. And how do I know this? It's given. Okay, then I can say the angle ECG is equals to 90. Why? Because of the tangent and the radius theorem. Tan-Rad theorem. The Tan-Rad theorem says that the angle between a tangent and a radius is always going to be, or tan center. It's up to you. You can say tan center. Tan center theorem says the angle between a tangent and a line from the center is always going to be 90 degrees. And therefore, the line FB must be parallel to the line CG because they have the same angles. Cool. Now it's a prove that triangle FCB is okay, let's do this. We need to prove then that the triangle FCB is similar to the triangle CDB. Okay, so here what you must always do here, when they give you this kind of question, what they want you to do is prove that F is equals to C and this C is equals to that D and then that B is equals to that B. Okay, let's start with the angle F. Why would it be equals to C? So let's look at in triangle C. Let me actually draw them out here so that it's much more clear the triangles we're working with, because I like to isolate it. FCB, it's this triangle right here. FCB, okay, and then the other one is CDB. Change the color to, let's go red. Not you. back to blue. Okay, and then I need a new one, is triangle CDB. CD, this one can be red. CDB. That triangle over there. Okay, so it's these two triangles. Right. Now, in triangle CFB, we want F to be equals to C. Why would that be? Well, F2 rather, let me say F2 is equals to 90 degrees. Why it's given? Because it follows that if F1 is 90 degrees, then F2 will be also 90 degrees. And then we can say B, C, D is equals to 90 degrees. Why? Because of the diameter theorem. Okay, the diameter theorem states that angles subtended by diameter are always going to be 90 degrees. Okay, so therefore we can conclude then that F2 is equals to B, C, D. Cool. Now we've proven that F is equals to C. Okay, now we need to prove that the C in this triangle is equals to the D in that triangle. So let's see. C is over there, that's C1. Okay, so we can say C1 is equals to D2. Why? That's the 10 chord theorem. Okay, just like that. So the 10 chord theorem states that the angle between a tangent and a chord is equals to the angle opposite that chord. There we go. We've proven that. And then for the last one, we can say then the last one, which is the remaining angles. We can then say the angle, I need to see it a little bit, B and B. Okay, we can then say angle B2 must be equals to angle B3 because of third angle of a triangle. Angle of triangle, just like that. So therefore we can conclude then that triangle FCB is similar to triangle CDB, just like that. Okay, and then let's go to the next question. It says give a reason why G2 is equals to 90 degrees. Okay, if you look at that, really, this is now question 10.2.2. We'll use a different color. Let's go green. Give reason. So we're gonna say that G1 or G2, G1 is equals to 90 degrees because center and the theorem between center chord theorem. Center chord theorem. Okay, that's it. That's all I'm gonna say there. Center chord theorem says that the line between, from the center to the chord bisects that chord and forms 90 degrees. So that's it. And then it says 10.2.3, prove with reason that CD squared is equals to CG times DB. Okay, so we need a game plan also here. The way that we're going to attack this one is that we're going to say CD. Let's identify CD. CD is over there. Good. And then CG, where's CG? CG, there it is. Okay. And then DB. DB is over there. Okay, let me change the color of that one to say green. Yeah. So here it looks like we will be dealing with two triangles again. This green triangle and that red triangle over here. That's going to be red. Okay, so we got two triangles, as you can see. We got green and red. Let me see if I can zoom in a little bit. Okay, so now this would be question. Let me change the color to purple. This will be question 10.2.3, I think. Yeah, prove with reason CD squared is equals to that. So what I want you to do is not to worry about this for now. All you have to worry about is that we're working with two triangles. Okay, and we have to prove that these triangles are actually similar. Okay, so let's start here. What can we do? We can say we're working with in triangle CBD and triangle CGD. Okay, we want these triangles to be similar, right? So what we're going to do then is that we're going to say let's look for the equal triangles. Okay, so first of all, we can say in CBD, we can say that the angle C in CBD is actually equals to the angle G. Okay, and both of them are equals to 90 degrees. Okay, this has been proven. No. Did we prove that this angle is actually 90? Oh yeah, we have. It's the diameter. It's the diameter. See this angle over here. It's 90. Good. And also this one is 90. We've proven it as well. So that's why I'm saying they're equal. Both are 90. Okay, we need another angle now that is going to be equal. Let's see. What about, is there a reason why C3 would be equals to D2? Yes. So we can say angle D this side, angle D this side, from which is actually D2, is equals to the angle C on this one, on the red one, which is actually C3. The reason they are equal is because of isosceles triangle. It's an isosceles triangle, and from an isosceles triangle we know that equal angles equal sides. We spoke about this, that the sides are equal because both of them are radii. Okay, so the angles must then be equal. Cool, that's what I'm saying. Okay, now we can say that the last ones, which is angle. Which one haven't we used in this triangle? We've used C, we've used D. It's angle B. So which is B3 in this case, must be equals to angle. Which one haven't we used? We haven't used D this side. The angle D, and the reason is third angle of a triangle. Third angle of a triangle, just like that. Okay. So now we can then say that we must put these in order. So we can say, start with this one, triangle CDB is now similar to triangle GCD. GC, how am I writing that? C? It's not how you write C. GCD. See, I put them in this order. It's very important to put them in their order, because now I can do this. CD over GC is equals to DB over CD, right? And then CB over GD. Okay, these will help us to solve our equation. Now, if we look at the question, it had CD, so we're looking for the one with CD. This one has CD, this one has CD, so we'll probably take these two, right? So we'll say CD over GC, and then DB over CD. Now if we cross multiply, we're going to get CD times CD, which is CD squared, is equals to CG times DB. There we go. That's our final answer. So that's it. CG and GC, same thing. Alright. Okay, let's move on to the next question then. And then the last question says, hence, which means we'll probably use this, well, what we just proved above. Prove that DB is equals to GC plus FB. Now, don't worry too much about this. We always worry about the what is there. Okay, so let's work with it. Let's see from our triangles here what we are working with. So first of all, we're going to identify what we're working with. They want DB, so let us identify DB. There it is, BD. Cool. And then they are saying is equals to CG, so there must be a CG in the equation. CG, and also there must be a FB. FB. Okay, it looks crazy, but really we just want to identify the triangles that we will be working with. Okay, now if you actually remember, we are looking for that line, and we have a 90 degree here, right? which means if we look at this entire triangle here, if we look at this entire triangle, it means we can really do Pythagoras, right? This is the hypotenuse that they're looking for, which is BD. Okay, so we know CD already is given by that. Okay, we need something else. We need BC. Okay, probably what will help us then is this, which was given here, this one here. Remember, let's not now, let's do this. This is 10.2.4 now. So first of all, what I want us to do is take this one, triangle FCB. Remember, these are written in order, similar to triangle CDB. So what we're going to do, we'll do the same as we did on top. FC over CD is equals to CB over DB is equals to FB over CB. So what are we looking for here? Why did we just do that? We want the angle CB, so we're gonna look for the ones with CB. Let's CB there, let's CB there. So we're gonna take these two, and if we cross multiply them, we'll get that CB squared, because it's two of them, is equals to DB times FB. Okay, why did we just do that? Well, we can do Pythagoras now. We can say Pythagoras says DB, I wrote DB, yeah. Pythagoras says DB squared is equals to CD squared plus CB squared. Okay, this is Pythagoras. Okay. Okay, let's go fill them in now. What is CD? CD, there it is CG times DB. Okay, I'm taking it from there, the purple one, and then now we need CB squared plus CB squared is DB times FB. Okay, now all we need to do is factorize, because you see both of them have DB in common, so we can take out DB. If we take out DB here, we're left with CG. My C looks like a G. Anyway, it's a C. And then this side, if we take out DB, we're left with FB. See what's gonna happen now? Yes, we're gonna divide both sides by DB. It's gonna cancel one of that, and we will have DB now is equals, that's if we divide both by DB. By DB. Okay, we're gonna have DB is equals to, I'm gonna write it exactly like they wrote it here, CG plus FB. There we go. We're done. Well, that's it for me. I hope you understood everything that we did. I tried to explain it step by step, but in the event that you didn't, we are available to tutor you. Please do contact us. Our contact information is under here, this video, or also you can comment. But please do like and subscribe to our channel. It will help you also to get future uploads that we make, because we always do these papers. So make sure that you stay tuned for that, the next one. Well, that's it from us. This is the last question in this paper. Catch the next one. Thank you so much. Enjoy the rest of your day.